Tá ótimo, está excelente.
Yeah.
Shall we start something? So, 5 minutes late. Okay, so hello, welcome to the first session of the second day of the ST30 workshop. And the first speaker is João Mota, who is going to talk about behavioral up-down casting for statutory type languages.
Okay, thank you so much, and good morning. So the work I'm presenting is the result of a collaboration between myself, my advisors, Dr. Marco Giunti and Professor Antonio Ravara, and PhD student, as myself, Lorenzo Bacciani, and his advisor, Mario Bravetti, from the University of Bologna. Okay. Also, just a few comments. So we started collaborating since 2021, I think, with some papers published on coordination, on work related with session types. But the setting I'm presenting in particular has to do with object-oriented programming. So when you think about executing actions, think in terms of calling methods on an object, okay? So as you probably are aware, it is very natural in object-oriented languages to create objects where the internal state influences the methods that may be called, okay? And also influence the sequence of method calls that are allowed. So a classic example is of an iterator where one needs to call this next method before calling next, otherwise an exception might be thrown. And we use type states to precisely define the behavior of these objects in terms of finite state machines. Now, our research question has to do how do we improve polymorphism support in an object-oriented language with type states. So to deal with polymorphism, we need to deal with things like subtyping, inheritance, and in particular, in the work I'm going to present, we are going to deal with casts. So suppose that we associate a protocol with a given class. That is what we do. We associate one protocol for each class. And suppose we want to downcast or upcast an object that is in a given type state. What should be the resulting type state the object is in after the cast? That's the question we want an answer to. Before discussing our solution, I want to discuss a bit about subtyping. So let's suppose that we have two classes, B and A, where B extends class A, and each of these classes have the given protocols represented by these finite state machines, okay? And first of all, we need to ensure that one protocol is a subtype of another. And we do that by taking the initial states and executing an algorithm based on synchronous session type subtyping to figure out, okay, does B1, the first state of the protocol of B, simulate state A1? And to do that, we execute the algorithm, which tries to find a simulation relation where that pair is in the relation, and we found out, okay, B1 is a subtype of A1. But of course, we need to be careful. So we are interested in figuring out all the states, all the subtyping pairings. And of course, if we just take the pairs that we got from this relation, we might miss some other pairs, namely one that I will show you. So for example, again, with the same protocols, suppose I have a piece of code where I initialize method B. So it starts on state B1. I call method 1, so I go to state B2. And then I want to pass it to another method which expects an object of type A. This should work because B extends A, but in state A1. And the question is, okay, is this safe? So it is safe if B2 is indeed a subtype of A1, and it is. And so we actually need to execute the subtyping algorithm again to see if we can find a simulation relation with a pair in it. And we find out, okay, B2 is also a subtype of A1, okay? So using this intuition of being careful of running the subtyping algorithm enough times, we will use this intuition to deal with casts. Okay, so this is all the subtyping pairs that exist given these two protocols. So B1 is a subtype of A1, B2 is also a subtype of A1, and B2 is a subtype of A2. So now let's get to our objective, dealing with casts. So now, again, let's consider two classes, B extending A, but with two slightly different protocols. So just consider that we have an object that right now is on state A2, and we want to downcast to class B. To figure out what should be the resulting type state in B, we'll use our intuition and find out which type states in B are subtypes of A2. But now we find out that there are actually two of them. Either we may be on type state B2 or B3. So what do we do now? What do we choose? Well, we actually don't need to choose. So instead of just having type states, we will compose them using union types. And so the result of downcasting, in this particular case, is the union of B2 or B3. And if, for example, I want to call a method on this union type, I need to ensure that action is available on both states. So in this case, only B2 would be called, which makes sense because originally A2 also allowed M2. Now, to deal with upcast, we do something similar, but in reverse. So let's see. So again, classes B and A, B extending A. Now different protocols. Let's consider we are on type state B2 and we want to upcast to A. So now we look for the super type states on A of B2. And again, we find that there are two of them, A2 and A3. What we do? Well, we could also produce a union, but we can actually be more precise, and we will compose these two states in an intersection type. And so we produce an intersection of A2 and A3. And any call that is available on either of them would be allowed. So on the intersection A2, A3, we could call M3, M4, M2, which also makes sense because in this example, B2 precisely allowed these method calls. Okay? So we started with type states, and now we have composed them with union and intersection types. But in fact, we found out that that is not enough for purposes. So I will motivate a structure that we introduced. You already saw the name, so type state trees. But I will motivate that with this very small example. So now we have the same class A, but now with two classes, B1 and B2, extending A. And for explanation purposes, let's just assume that A, B1, B2 all have the same protocol, so the mapping between type states is obvious. So S1 in protocol of A will also match S1 on protocol B1 and B2, just to keep things simple, okay? But our approach is general enough for any kind of finite protocol. But now let's look at the code. So as you see, we have an if branch. In the first branch, we initialize an object of class B1, on the second of B2. And the question is, okay, what is the type of A after the evaluation of this if branch? And another question that we could ask is, okay, what if I downcast to B after the if branch? Can I somehow preserve information, whether it was B1 or B2, and if it was B2, what was the type state it was in? So that's why we introduce type state trees, as we will see. So the type checker we developed would start by looking at these expressions and associate them with a very simple tree with just a single node, the root. So this expression would be associated with a type state tree with root saying that we are in class B1 on state S1, and then in a similar fashion on class B2 and state S1 on the second branch. Now you see that we assign to a variable with static type A. So we need to perform an upcast. So what we do is utilize the previous approach that I presented and look for the super types in the protocol of A. In this case, it's very simple, so it's just S1. And so we build a new root for each tree associating class A with type state S1. And now, to answer the question I presented previously, what is the result after the if branch? Well, it's just merging both trees. So we end up with this type state tree that we know for sure that the object on A is of class A on type state S1, but in the case it is a B1, we are in type state S1, or we might be on class B2 and also type state S1. And so when we downcast in this simple example, what we do is, okay, do I have information about the object in case it's if it is an instance of B2? And in this case, okay, we have that information and we can just reuse it. And so the type state associated with this expression is the result of just taking this node and building this new tree with just a root. And also to clarify, so our type safety approach is essentially, we provide type safety up to downcasts not throwing at runtime. So as you might imagine, I'm not sure this is a B2. It could be actually a B1 at runtime. I'm not actually checking the instance, okay? But the idea here is that if this downcast works, then the object is in B2, is of class B2, and if that is the case, we can be sure it's on type state S1, given the information on the type state tree. But now let's suppose that I do a downcast to a class that is not represented statically on this type state tree. What do we do? Well, we can use the previous approach. We look for the subtype states in the protocol, in this case of C, which extends B2, and try to produce a new type state tree. And again, in this very simple example, we figured out, okay, we only have S1, subtype of S1, and we create a new type state tree with root associated with class C. And so our contribution was essentially the definition using type state trees, composing them with types, in particular union and intersection types, and then using them to construct type state trees. So there is, let's say, an evolution of things constructed on things more basic. And we developed a language agnostic theory. So we believe we can apply this to any object-oriented language, such as Java. And we provided the definitions, and we developed unwritten formal proofs, also supported by the Coq proof assistant. Okay? And we applied this in practice in a type state checker for Java, actually called, as you might imagine, a Java type state checker. Okay? Which is built on the checker framework, very used on the Java community, and provides the following static guarantees. So we ensure that methods are called in correct order according to the protocols of each class, so what we call protocol compliance. We also provide protocol completion, that is, we ensure that if the program terminates, all the objects reach the end state. Okay? And we also avoid statically the so-called $1 billion mistake, null pointer exceptions, because they might occur often in languages like Java, as you know. As future work, we of course need to connect this theory with a formally defined core language so that we can actually prove type safety. So that is a result that we have not done yet, but we trust that we can do it since we also got some practical results from testing with the tool I presented, okay? And we plan to accomplish this by extending the type system presented in this paper that you can see below. The tool is open sourced on GitHub in case you want to try it out. There are several examples and tests that you can also see. Thank you so much for listening, and I'm available for any questions.
Thanks for the talk. So right at the beginning, you mentioned the iterator example, and you said something about JEDIS.
In passing, yeah.
Do you have any examples of whether or what kind of what kind of applications you've looked at, what kind of practical classes you've defined type states for, and what kind of programming situations where you're using casts, and do you have examples of sort of successful and unsuccessful situations where you're trying to downcast and it doesn't work, or
Yes, we have some examples. Also in our repository online where we use casts. So let me think of an example. We have, for example, an example of some cards, for example, and we have a hierarchy of classes where we have an abstract card, and then we have specific kinds of cards with different functionalities. So, for example, an SUV with some special modes like sport mode and stuff like that. And we have some examples where we try to perform some casts. So, like, I have a car, but I don't know which car it is, and I try to downcast and see what is the type state I end up in, and things of that sort. Does that? Yes, okay.
Hello, thanks for your talk. Just a simple question, really. So, if I understood correctly, when you're doing the casting, it's like a Java-like cast, and you cast up or down to a class. Did you consider having the programmer explicitly specify not just the Java cast, but the state that you're targeting? So it's more restrictive, maybe, than what you proposed. But just wondering if.
No, so in this case, we follow an approach where it's more or less automatic. So given the current type state, we compute the type states, for example, in the subclass, if we don't cast, that we might be in. So there are some other type state-oriented tools where the programmer would, for example, explicitly say, this state extends this state, and then their casting is obvious, you see? But in our setting, we define protocols as finite state machines for each class, and so the mapping is not explicitly said, you see? And so I guess our approach is more automatic, but what we could do, and we don't do right now, is something like the programmer says, okay, but I expect it to be in this type state, and if the cast does not give me that, give me a static error. That is something for sure we could do, and we might do it in the future.
Okay, so yeah, I definitely see that. Did you? I guess what I'm asking is, did you come across any examples where it's actually very important to have this flexibility? Let's say, if it be too limiting to have to specify the state itself.
We would say that casting is often used in the object-oriented programming. I think we even mentioned here a paper that does an empirical survey on casting. Of course, out of my mind, sometimes it might be difficult to figure out examples where we use both protocols and casting. But we have some examples, for example, in the repository, like I said. And I mean, we would say that casting is a feature of object-oriented languages and polymorphism. And so we don't want to just put it in the side and say, okay, we will just ignore it. So, yeah.
So yeah, thanks for the talk. I had a question about, I think it's the same slide. Can you go back to the one with a small example with the if then else? Actually, maybe it's
afterwards.
Yeah.
So, 1 second. It's on type state trees, so it's this one.
Yes, a few more steps when you show the tree.
The result.
And the next step too. Yes.
Okay.
Okay. Okay. One is first of all, I guess your tree can have different states in the leaves.
Yes. Yes.
And then you apply the procedure shown in the previous slide to understand.
Precisely.
Okay. But the other question was also when you downcast, it looks like basically you don't have a tree anymore. Is it the case, or do you lose all the information about the fact that B2 derived from A and therefore?
So let's assume that we had here, for example, new C and C extending B2. We would have a node here below for C, and we would preserve it.
So
we would keep B2 as 1 and everything below when downcasting to B2.
Everything below, but not up. So if one upcasts
Exactly.
The result of the downcast, what happens? Can you recover the information about?
We recompute it. So because we have an invariant where the root class needs to match the declared Java type, you see?
Okay.
And so when I downcast to B2, the Java type associated with this expression is B2. And so the root should have B2. So we don't keep information about A, but upcasting generally is more simple. So we are just, I guess, under-approximating. But we would, if we were to upcast the result of downcast, we would need to recompute the root.
And you can do that, okay.
But it's usually, I think we get, because of intersection types, we usually get precise results, and so we don't lose much with that. I would
Okay,
say.
I see. Thanks.
Yes, we have some theorems that relate to downcast after upcast and upcast after downcast, and how they relate in terms of subtyping relationship.
Okay, thanks. Any other question? Or if not, let's thank the speaker again.
Thank you so much.
Move them back. Toujours.
A bit early. Sorry.
You're ready? So the next speaker is Gerard Tabone, and he's going to talk about session-based type checking for XIII modules using XIII, and this joint work with Adrian Francalanza.
Thank you. Just as I said, this is joint work with Adrian Francalanza, and we recently published this work in a journal paper JLab. So what I will be talking about is our tool, XIII, and we will see how we integrated session type within an existing language, XIII. So first of all, XIII was created around 11 years ago by Jose Valim, and it's gaining popularity. As you can see in the Stack Overflow developer survey, it was listed as the second most loved or admired language after the Rust language. And so XIII is a dynamically typed functional language. It is built on top of the Erlang ecosystem. So because of this, it can make use of features provided by the Erlang language. And one of these is the concurrency via the XIII model. So that means that an XIII can spawn processes, and each process can talk to another via message passing. And since actors are very lightweight, you can have thousands of them, for example, running at the same time. So currently, XIII provides most of its checking at runtime. Despite this, even the compiler and some other tools, for example, the dialyzer, they are able to cache some errors related to the functional aspect of the language. For example, if you call a function with a wrong number of parameters, then the compiler will complain. However, the XIII core team, the ones that maintain the language, including Jose Valim, the creator, they are trying to move towards a statically typed language, while obviously maintaining the current like backwards compatibility with current XIII programs. So they even released very recently the design of a gradual type system where they covered most of the functional part of the language. However, in their design, they are not considering the concurrent aspect of it. So they don't care, they don't check, for example, the messages being sent and received. So this is the part that our tool, XIII, will target, the concurrent aspect of the language. So we target one specific pattern. So consider like one common design is when you have a server that offers some services. In this case, you have F1 up to Fn. And you have a client that wants to use the server. So what happens is the client sends a request, but rather than the server handling it directly, the server spawns a handler as a separate process, and then the handler runs the required functions, for example, F1. And then in this case, the handler can interact via message passing with the client. Again, if there are any other clients, since the server is free, it can accept further requests and creates other handlers. As I said, we target specifically this pattern. What you see here is what happens like at runtime. Like, however, when you look at it from a static point of view, like at compile time, you might only have the code for the server, because the clients might be made up from different parts that you don't have access to. So because of this, we will only focus on the server. So like programs will be composed as modules, and each module will have some functions, like we saw earlier, F1 to Fn, that clients can use. Rather not use directly, but use them when they are running. And internally, the public functions can make use or offload some of their work into some other private functions. So in this case, the functions G1 up to G5 can be used by F1 up to Fn. Now, the important thing about this is the interaction that happens between the function, the process running F1, for example, and the client. And this interaction follows a notion of protocol. For example, the F1 here must follow some protocol, S1, and on the other side, the client must also observe a compatible protocol, in this case S1 bar. Currently, in Elixir, there's no way to specify these protocols. So what we do is, by our tool, XIII, we provide a way to write them, to link a function to a protocol, and also to check them, to type check these functions. So let's consider a simple example of a counter system. Here you have two processes, a server and the user, where the server keeps some running total. And on the other side, the user can, for example, either increment the total or read the current value, or else terminate the session. The server part can be implemented as this module counter, where you can see two functions. So there's a function called service that takes two parameters, the PID of the user and also the total value. So what happens is the process waits until it receives a message, and that message has to either be of the form of increment, it can also be read or stop. So if it receives increment, then it increments the total via tail recursion. If it receives read, then it calls the private function read, where the server sends back the current value to the user. And if it receives stop, then it just does nothing. So if you look at it, you can see that implicitly it's following a sort of protocol. So this protocol can be written as this counter session type, where you have a typical binary session type, which is the branching type, where it can either receive increment with a payload of type number, where and then it recurses. It can also receive read, and then sends back a value of type number, and then recurses, or it can also receive stop before terminating the session. So this is fine. However, what happens if, so this compiles and everything, but if the developer makes a mistake in one of these messages, for example, sends a different message than the one expected. So the question is, what happens then? So what happens is that the program will compile successfully. However, when it is running, the process will either crash or it will just block. So in this case, consider some examples where I commented out the read branch. So on the other side, you can have a client that is expecting the server to process read messages. However, in this case, it does not. So it violates the protocol. Another example is you send an incorrect payload type. For example, you send hello, which is a string, instead of sending a number. This is also a violation. Or you can send some random messages, which may also influence the execution. So how can we add the session types to our functions? So if you have a function, we can add them using annotations. These two annotations, the add session and add DUL. So via the add session, you can create a labeled session type directly, or with the DUL, you can just reference the DUL of some session type. If you have a private function, since it will be called from other functions, you don't have to annotate them because it will inherit the protocol. Why did we choose annotations? So in Elixir, it's very common to use these to add information. For example, the compiler, you can use the add doc to add function information to the documentation, or the dialyzer, for example, it provides the add spec to add type information to the functions. Okay, so we integrated it directly within the compilation pipeline of Elixir. So typically you have some Elixir source code, which then compiles into the Elixir abstract syntax tree. Then the macros are expanded before being converted into Erlang abstract format and core Erlang before ending up as being bytecode. So what we do is we take the bean bytecode, from it we take the Elixir AST with the macros expanded, and then from this you can take the annotations and compare them to the functions. So I want to give a short demonstration of our tool. Is it too small, or should I? Is it better? Okay, so here we have the counter module that we saw earlier. You have the service and the read functions that I explained before. But for convenience, I added another function called user that will act as the user part of our session. So what the user does is it takes the PID of the server, and it sends two messages here to increment first by 5 and then increment by 2. And then it sends a request to read to the server before, and then afterwards it waits to receive the value, outputting this value, and finally it requests to stop the session. So this is running without session types. So I just want to run this. So I open the Elixir shell. So I want to initiate a session that runs on one side that runs the service. That takes, that sets the total value as 0. And on the other side, I wanted to start a process running the user function. So first of all, this compiled correctly because there weren't any issues. And now I can also run this. And as you can see, it runs well because it tells you that the total value is 7, and then it terminates. However, if I make some mistake, for example, I send, instead of sending 2, I send the string 2, then I will try to recompile, and as you can see, it compiles correctly. However, if I create the same session that we saw earlier, at runtime, we run into some issues. So we'll use our tool to catch these kinds of issues beforehand. So to do this, I will link our library, our tool, and then I will add the session type counter before I will link it to the service. So I have this session type counter. It's the same one as before. So now the service function will be following this session type. And I also want the other side, the user, to follow the dual of the same session type. So now, if I try to make some mistakes, for example, the one that you just saw, and I save it since the language server compiles the file, it immediately shows up these issues. So it shows that on line 26, it has an incorrect payload type because it expected binary, which is a string. Another example would be to send a random message. For example, you send the message hello. This is also incorrect because hello doesn't match with any of the choice type. Because as we said, you can either send stop, read, or increment, and hello doesn't match with any of them. Or you can forget to send some messages. So if you forget to send a read, then you will get an error because you try to receive before requesting to read. So this is also a violation. Okay, so I return back to the presentation. So I want to analyze it, show you a bit the formal part of our tool now. So first of all, if you recall this diagram, when you have a function, you have a module that has several functions, as we saw, and the function has somebody of type of the body of the function. The body of the function will be a term t. So a term can take the form of an expression, function calls, for example, branching via case can also be send or receive. So to type the terms, as I mentioned before, there are existing type systems. However, the ones that exist, or at least the ones proposed, only consider the functional part of this language. So they don't consider the messages being sent or received. So what our aim is to expand on this and handle both the functional and, but more importantly, the side effects, like the messages being sent and received. And to do this, we use this typing judgment, which states that if you have a term t of type t that follows some initial session type s, when it finishes executing, then it will end up with some session type s prime. this only works under two assumptions: the function type environment, delta, which is used when you recurse, and we also have the typical variable type environment, gamma. And finally, we make use of use a form of dependent types to include the dual PID, so that we can know that we are sending messages to the correct address. So I picked one example, the receive branch. To type this, we just I think it's typical. So we just have to compare that the labels match the ones offered by the branching session type. And we also have to make sure that the patterns that we offer, that we have in the receive construct, contain only simple types. So they have to be either variables or tuples. So this way we exhaust all the possible pattern options. From these, we extract the variable types using this pattern typing judgment. And then we just have to type check the continuation TI against the continuation session type SI. And then all of these terms must end up with some common session type S prime. Okay, so I presented like the tool and a bit about its type system, but how can we like make sure that it works, or how can we validate it? So our aim is to present the session fidelity property, but to do that we have to present the operational semantics. So here, if you have a process executing term t, when it transitions to a new state t prime, it will create some side effect. It can either be some side effect, the alpha, that we call action. So this action can either be an external one, an external action. That means a message is being sent. In this case, it sends a message, or it receives some other message. However, you can have some internal action tau. So if we look at one example, the receive construct, in this case, if you have a receive construct that receives a message labeled L with some payload v tilde, what happens is we compare the patterns from the branches to the values using the match function, so that we extract the substitutions required, so that when this transitions, you end up with tj, or some of its variables are substituted. So this leads to the session fidelity property, which says that whenever you have a well-typed term t against some session type S, and this term transitions to a new state t prime with some action alpha, then there are two options. So if the action alpha is an input action, so the process receives a message, then we have to check that the alpha is valid. And if it is, then we know that the new term remains well typed. On the other hand, if you have a different action, we immediately know that the term t prime is well typed. Another property, the last property, is a form of progress, which says that if you have some term t which is well typed, then either the term is a value, or else it is able to transition to some t prime using a valid action. So to conclude, so currently you only handle 2 processes at a time. So it would be nice to be able to handle multiple ones. So one way to do it would be to use the multi-party session types. But another, maybe more suitable way would be to use intuitionistic session types, because when you have vectors that spawn other vectors, you might end up with some tree. Another option would be another avenue would be to handle process failure and supervisors, and also some other Elixir behaviors, such as gen server and agents, because all of these are critical Elixir functions. And the last thing would be to be able to account for resource usage and cost, to be able to, for example, keep track of how many messages are transferred. To conclude, so I presented this tool. It was created in Elixir for a core part of Elixir. I constructed an operational semantics and also a session typing system for the Elixir subset. And we showed that it observes a form of session fidelity and progress. So thank you.
I have a question. So one is technical about the typing, about your typing judgments. So why do you have this pre-type and post-type? Is it because you need to type semicolon, or?
Yes, because you have the sequencing. So that's part of it, and then the remainder has to be done by the remaining term.
And then the other question, very quickly, it was about, I saw your example, right? And your example is just a request reply. And the question is just that I've also been able to see many examples. Do you have something that is a bit more complex, where the type is a little bit more structured? I mean, real life, like applications, where they don't use this request reply.
So in the paper we have some other example that uses, I think it's a flight, uses a flight API, so it checks like flights and stuff. And part of it is type checked using session type. But one issue that at least I found was the session type increases quite a lot. So if you have a complex protocol, a complex indirection, it gets a bit large. But you can. In the paper it's linked, but I don't think I have it open right now. But I think there are.
Okay, yeah, I think actually following up on that, it's natural deduction rather than sequence calculus, Marco. Yeah, I think so, right? I also have a question on the typing judgment. So for the context, no, the slide you just were at, yeah. So gamma, is it a structural context or a linear context?
So it's not linear because variables can be used multiple times.
Okay.
So we don't care about linearity.
Okay.
In this case.
So that's kind of what I gathered from your explanation. But then, how do you account for the state changes? Don't you need some form of linearity? And I think related to that is, maybe I should first ask for the W on the turnstile. You said that's, if I understood correctly, that it's a recipient.
Yes. So we handle the dual, like the address of the dual, kind of separately from the variable. So we try to not change it, so that we will know who will be receiving the message.
I guess a related question, because I'm not quite sure, but I can otherwise take it offline. Are there any channels at runtime? And
sorry?
Are there any channels at runtime, or do you have like those recipients? Are they just static notions?
So since we are using Elixir, we're not using channels at all.
Okay.
Like we're only using not the full actor model, but part of the actor model. So we can only send to some process address.
I see, and that address is statically known.
Yeah,
Okay,
that's
got
statically
it.
known, like the variable of it, because
Yeah.
it will be known at runtime.
Ah,
But the one holding the address is statically known.
yeah,
actually.
okay,
Yes,
makes sense.
yes.
Okay, thank you. It was a very nice talk, by the way.
Thank you.
Yeah, thank you. So this follows up a bit, I think, on Stephanie's question. So you're dealing with mailboxes rather than channels. And you said right at the end that you're dealing with sort of one client, one server. So this is what enables you to really use a session type, because you're just looking at the sequences of messages from one client to the server. You're not worrying about the fact that there may be several clients sending communications into the server's mailbox. But can you? So okay. So the first question is: so does your type checker check that you have this situation where there's only one pair of processes interacting? So do you, if you write two clients with the same server, do you get a static type error?
So since spawning the session is not part of the type system, we kind of do not check for it. But we assume that you only have like a process and it's dual. So yes, exactly.
So would it also be the case that, so in this example, you've got a server and a client. So is it also the case that, say, the client one can't also be a client of some different server at the same time? Because then client one would be receiving messages from two different servers and they wouldn't be described by a single session type.
We do not consider for a tree right now, for example, like a client connecting to two handlers. Like
Okay.
we do not consider that.
Okay.
Just to consider a single interaction between two processes.
Okay, thanks.
Thanks for the talk. Actually, probably the previous questions asked my questions. So you don't have channels, so that's why you're not bothered about linearity, but what you give up is that there's no interleaving of multiple sessions or interleaving of sessions within a function. Is that right?
Exactly. No,
Okay.
we assume that there are no interleavings.
Okay. Is that something that you want to do, need to do, or is that totally fine as it is for Elixir? Or?
For the simple kind of design, it's fine, but it would be nice to be able to handle larger, more complex systems.
Do you have any ideas about how to do that while still bypassing linearity? Or?
We're not, I mean,
Okay, sure.
I'm not sure.
Other questions? Maybe there is time for one more. Otherwise, I have a quick question, but maybe meanwhile the next speaker, if they are in the room. So, okay, surprise. So maybe the next speaker can start setting up if they are here. Or is it a remote talk? Okay, let me.
It's not remote because it's not
Yeah.
showing up.
Cancelled. No, wait, no, sorry, no.
Not as well. So they should be here.
So it should be Dimitrios Eliades or Dimitris Kouzapas.
Yeah.
No. Dimitris is not here, I think.
I don't know. I assumed that Dimitris Kouzapas was going to be giving this talk, but I haven't had any communication about it.
Okay, I will ask a question and then see if we have a surprise. I don't know, a last minute appearance. So I had just a quick question about, so I noticed that basically you type annotate with session types that say the server function, but then you can call other functions that may handle part of a protocol.
Yes.
But those are not type annotated. So I was wondering, so do you infer their type, let's say, bottom up from the, and then compose it, or do you flow the type checking inside the function from the top, let's say, from the calling point?
So when it is called, it inherits the remainder of the protocol. That's how we handle it.
So it's like top down, basically, from the
Yeah,
caller
yes.
to the callee.
Exactly.
Oh, okay.
Exactly.
So does it mean that you may, in principle, have the same function used by two servers with different types, as long as they match in this?
Exactly.
Okay.
Exactly.
Nice.
Mhm.
Yes. Maybe yeah. Let's take turns. Thank you.
Hi, thanks for the talk. Just curious, do you allow for any kind of subtyping of, maybe not sessions, if because I didn't see it implemented, but maybe the payload values of the actual types in Elixir? I'm not sure if it has a subtyping system and you allow for it.
So in the type system, we do not handle subtyping, but in the implementation, it was easier, for example, to handle, for example, in Elixir you have atom types, and you can write an atom directly, so that becomes a subtype. So in the implementation, I have a bit more flexibility, so consider a slight sort of subtyping. But in general, no, we don't handle it.
Keep going. So you can write a, it's Elixir programming, so you can use features of Elixir and things like that. So how much integration do you have with your type checker with arbitrary Elixir code? Is there some restrictions on what you can write and type?
So we only consider the core subset that I showed. Because
Okay.
the problem would be that since it's dynamically typed, you can have, for example, function calls that do something that is unknown.
Is the progress property that you showed, does that apply to fully in practice to the subset that you, there's no way to deadlock or something like this because of all single sessions only and something like this, I guess?
So the progress property. So if I don't have this diagram, since we only consider progress for half the session, so we are kind of assuming that the other side will be following the compatible protocol. So progress works for that one side.
Okay. I'm sorry, just very last question. If you go back to your typing judgment.
Sorry?
If you go back to your typing judgment, so this looks a lot like these effect system type approaches, or flow sensitive effects and these sorts of things. Have you looked at those kinds of things? Or?
I'm not familiar.
Okay.
I don't know.
Maybe we can talk a little.
Yeah. Okay.
I think we can thank the speaker again. And now, do we have any news about the last talk of the session?
What I can say is about until 8 days ago, neither of these authors registered for SPLASH'. I don't have a recent I have been cited for
colleague an email about that. Here,
So I think some people got an email because when they were defined as a chair, they got an email from the SPLASH system saying you would be
Yeah.
registered as a chair or something. But I don't actually know whether Diana and I sent you.
okay. Well, if I did, it was forwarded to the spam folder.
That could be.
So that's perfect.
I mean, it was an automatically generated email, so it could easily go to the spam
Yeah.
folder, right?
Yeah.
No
I know that
reply
I
stuff.
volunteered, so.
Well, you did, and you even said which session you wanted to chair. So
Yes, I did.
although we've lost Lily, of course, the third talk. So
Yeah. So maybe you can be the lunch. All right. Let's get started. So this is a shortened session because Luis Carras unfortunately is sick and won't be able to come, which means that we can try to beat the long lines at lunch after the first two talks. So the first talk is on mixed synchronous and asynchronous sessions. Krista Peterson and Buko Yoshida. Krista?
Thank you very much. So as Nobuko already told you yesterday, the talk is about distributability. So I hope you are well aware that if you are not concerning distributability, there is no real difference between asynchronous and synchronous communication in terms of expressive power. But if you forbid for anything that reduces the amount of distribution in a system, then synchronous communication is strictly more expressive than asynchronous communication. And the talk is about finding out how we can maybe get a little bit of this additional expressive power to the session type setting, right? So we start with the pi calculus. Here, this is the full pi calculus where you have the choice construct on the very left, and on the right you have the prefixes that can appear in the choice, and you see that there is an input and there is an output, so you can have choices in that inputs and outputs can appear mixed, right? And it turns out for the pi calculus, this is really what makes the difference between the asynchronous communications and the synchronous and the expressive power of the synchronous communication. So there's other things that make a semantics, for instance, asynchronous or synchronous, but the expressive power, the additional that comes with the synchrony, comes from the mixed choice, right? And now I give you one session calculus. You can take the one that you like, but for the sake of this talk, we have this one. And there you can see that we have here selection and branching at the top line, right? And as a form of choice, and it doesn't really matter what kind of choice you find in this binary session types, they are all usually separated choices. So what you have here is you can select exactly one output, but something that resembles the output because there's somebody taking a decision on what branches to proceed. And then you have on the, so to speak, receiver side, several possibilities to react to whatever comes in, right? And so the general idea that you find of choice that you find in binary session types is that you have some kind of internal choice connected to the sender that makes a decision of sending one of several options, and you have on the receiver hand side an external choice that offers different ways to react to this decision. But that's it. You do not have a mixed choice, usually. Now, and that explains also why I called this calculus CMV. This is because of the three authors, right, of which we have one here. There was this recent addition, this recent extension of this calculus that indeed includes mixed choice. So we have here the choice construct again. I omitted linear and unrestricted prefixes, but they are in the language, but not relevant for this talk, so that's why I but you have a choice construct, and then you can use that for the branches, and you see there, you have a label and then a star, and the star is either a bang or a question mark for output and for input. So here you have a session type calculus with mixed choice, right? And that's really nice, and that's really something very new. So you can now express things like that. So you have here several choices in parallel. It doesn't matter that you have 2 for y, but you can look at the blue part and the green part to see that for y we have here a choice between an output and an input, and on the other endpoint of this session, on the x, we have a choice between an output and an input, and that's fine. It's a well-typed process in session types. So this is really nice, and it really adds a lot to the flexibility, right? There's examples in the paper for producer-consumers, for instance, where it really makes a difference when you're allowed to do that because you can express a lot of things more naturally. So it's really nice to have that, but and it really increases the flexibility in using this calculus. But then the question is, does it also raise the expressive power? Do you get a bit with this well-typed calculus, with this well-typed terms in this calculus? Do you get a bit of the additional expressiveness of synchronous communication, right? And yeah, that's the question that we looked into in a paper that we submitted to, or had at Express SOS last year. And what we wrote also there is we do not expect an increase in expressive power for linear choice, but for unrestricted, at least you should expect some increase in the expressive power, right? If you just look at that briefly. Actually, if you ask me, so we wrote that mostly because the reviewers always said, it's obvious that you don't get the expressive power of the full calculus. Nobody claimed it would be, but at least something more. So for me, already for the linear choices, it's not that obvious, right? You have well-typed, mixed linear choices. So is it really not anything more than you had before? It turns out, unfortunately here, the answer is that the mixed sessions do not increase the expressive power. They increase the flexibility quite a lot, and they're really nice. But pure expressiveness, if you consider only the expressiveness when they do not add anything, neither in the linear nor in the unrestricted case. So now what we are doing now is we look at that, try to explain why this is that, like that, so to see what else we could maybe do to indeed get something for the expressive power of synchronous communication, right? So that's the idea. Okay, so how did we prove that it does not increase the expressive power? And believe me, it's really not easy. So I had a first view on this calculus, and of course they asked me some question and I answered that. I had not much time to look at the paper by that time, but I did not spot that it would not increase the expressive power, and this is something I'm really working on much, and I did my PhD on and stuff. And still it really needs to a lot of detail and techniques to figure out why you don't get more, right? So it's really not an easy answer or analyze. So why is it that? In the paper, we did the following analysis. So first of all, we took the leader election problem and compared that, because in the pi calculus, to show that there's a difference between the asynchronous pi calculus and the synchronous pi calculus, leader election by Palamidesi was the first what was used to prove that there is this difference, right? So we just revised this proof technique in order to show that there is really also a difference in the expressive power here. But then we went to one of my own research results. We went to the so-called synchronization pattern. It's smaller, it's more wider applicable. It's I show you this, the definition later, but the basic idea of a synchronization pattern is to capture what kind of structure you need in a term to have this kind of power in communication, and this is for synchronous communication. You also have a synchronization pattern for asynchronous communication, and then we looked into whether we find that kind of structures or not, right? So it's more basic. So the idea is basically, if you do not have stars, you cannot solve leader election. But of course, with the stars, you can do more than just leader election. It's not just one problem. So it's not, if you just show that leader election is not possible, there could be something else that you could do with synchronous communication that you cannot do before. So I mean, the question is always, do you add something here, right? Okay. And then the third thing that we looked at in the paper is an encoding what was given in the original paper, right? And that also tells you a little bit about why you do not really add more expressive power. And now for the talk today, I will talk about these results from this XPress-SOS paper and then add one more step, which is not in the paper, namely, can we build a semantics, an asynchronous semantics for the CMV plus, for the calculus with mixed choices?
I have a comment that Vasco proved soundness, but they do not prove complete.
The other way around.
We did.
Yeah, the other way around, but yes. We added the soundless proof for this encoding. Yeah?
Sorry, I'm a bit lost. So are there types involved in this diagram? So you have types for pi, types for...
I will come to that, and no. Because the problem with not having the expressive power of mixed choices here is not depending on types. It has nothing to do with the types, the syntax and semantics of the language itself.
And that's the synchronous pi calculus, right? So that's
The PE, it's synchronous pi calculus, yes. So it basically means that you cannot encode into the pi calculus into that because you are missing expressive power in the... I mean, that is not the surprising part, but it's really how much expressive power you miss. That you really don't add something. Yeah?
What do you mean by linear choices?
Linear choices? Did I say? Sorry, if I said...
Linear mix of choices.
Linear, sorry. Linear and unrestricted are the predicates. So unrestricted is shared names, and linear is the
session channels.
The session channels.
But they are not typed.
I mean, the languages are well typed once, but you don't need the types.
My question is, if you are asynchronous and you have that mixed choice, you break subject reduction. Right?
No, they have...
It's synchronous. No, if you're asynchronous.
Yeah, wait, two things. So the original semantics of the calculus is synchronous.
Okay.
But the expressive power is that of an asynchronous calculus. And that's why we are able to give the semantics using queues.
Okay.
That's basically what we do, right?
Yes.
And this last part is the new bit about it. Since the expressive power is that of an asynchronous language, we are able to give the semantics with queues. But you have to do something. Okay. You cannot naively do that, because then, of course, you get into all the trouble that you would expect. Deadlocks and additional behavior and whatnot, right?
I'm sorry, I'm very confused. I'm sorry to interrupt. But so the idea is, so you show that you cannot encode a linear relation in this plus language, right? And it's because of the same argument as Palavides' paper.
It's not the same, but it goes along the same lines, yeah?
Yes, and then this enables you to assume that there is something asynchronous about this language.
It's more. No. It's really from this.
Talk about the last
item.
Yeah. Let's forget the last item.
We just used that to come to this conclusion. Okay, so start.
Forget about the last item because confused.
Okay, let's start with leader action. I hope you are all familiar with that.
We are proving synchronous mixed choice has the same expressiveness as without mixed choice, and we cannot encode usual leader election.
Or anything else that you expect from synchronous.
But let's think only synchronous now, because confusing.
Okay, so leader election. So what is important here is that it is a symmetric network. If you do not have a symmetric network, you cannot use that to distinguish synchronous and asynchronous communication. So the difference is really, if you have a synchronous network, where synchronous means the processes are allowed to have an ID, but are not allowed to differ in anything except for this ID, and the IDs should not be ordered. So you cannot use the IDs to choose a leader. Every ID has the same probability of being chosen. Right? That's the basic idea. And then you announce a leader by sending an output on the ID. So you use the IDs as channels. This is the easiest way to do that. And then if you are ID 3 and you want to be the leader and you think you have succeeded, then you send 3. Message on channel 3. Right? That's the way. And then you solve leader election if you have no such 2 messages. And in every run you have exactly 1 of them announcing himself as leader.
And I can only nominate myself because I cannot.
Yeah, I mean, this is the way it works. It's not really required, but for the example, it's basically like that. So this is a leader election in the pi calculus. So this is the terms that you have. You put them all in parallel, right? They're depicted here. So it's 2 stages. On the one hand side, you have the circle in blue, and you have the communications that are depicted here. For instance, here you have a communication between 4 and 3 on channel C, right? 4 is sending in C output to 3. And the receivers are the ones that winning this binary part. And since we have 5 processes in the beginning, it's exactly 2 communications that are happening. So 2 processes are left for the second stage. And in the second stage, we have the star-like structure. And that then, again, the receiver of the last 2 processes, right? One is sending, the other one is receiving, and the receiver wins still in the game. And you see that that is one of the derivation that you get. And you see, in this case, number 3 had 1. And there's some junk left over, but that is not observable. So this is just a stuck process that cannot do anything. Right? And all the other runs of this term are symmetric to this one. So the only thing that changes is basically you get another piece of junk and you get another leader. But you have exactly 1 way for each process to win. Or exactly 2, I'm not remembering. But it's the same amount, the same probability for every ID. Okay, so this is leader election for the pi calculus. So why does it not work for the mixed session calculus? The problem is we cannot solve leader election in simulating networks of odd degree here. Because if we try to do that, we can construct a potentially infinite sequence of steps that always restores the symmetry of the original network. And of course, to elect a leader, I have to do something very asymmetric. Namely, exactly 1 is saying I'm the leader and all the others don't. And that's not symmetric, right? Symmetry would mean that everybody says I have an output, and the only difference is the ID that is transmitted, but that would not be a solution to the leader election problem. So you can go into infinity and never deciding, or you decide on 2 different things, or whatever you do, but it's never a leader election solution. And this is the same as with the pi calculus, so the Palamidesi result. The difference now is how we prove that. As in the original case, the main ingredient is a long confluence level, but with the pi calculus, the confluence is about inputs and outputs. In the asynchronous pi calculus, if you do an input, and if you do from the same term an output, then you can do the output here and the input there, and you end in exactly the same state. And this is not true with the mixed sessions. Of course not. You have choices that combine inputs and outputs. So if the input and the output is the same choice, there is no way to do after the input the output, because the choice is gone. So this is not true, so we have to look for something else, but we found something that restores another confluence lemma that gives us the same amount of proving, and this is the following. So you have a starting point with 2 options, and the one is that from P to P1, the only thing that changes is that there's a choice on endpoint A that is reduced. And in the other case, the only thing that changes from P to P2 is that a choice on endpoint B is reduced, and A and B are not the same. All the other changes for the communication partner happens in Q1 and Q2, and that's not restricted. But for the P1 and the P2, we require that this is really the only change. And if this is the case, then the 2 choices that are reduced from here to either there or there have to be different choices, because A and B are different session channels. And that means that then afterwards you can close again and reach the confluence. And this confluence lemma was really enough to re-establish the proof that you cannot do the encoding, right? So the reason here, that's why we do that. We look for the reasons. Why was it not possible? So the reason here was because the syntax allowed choices only for a single channel endpoint. That's the point. That's why it still worked, to show that it's not, that you cannot encode the leader election. Okay, synchronization pattern. This is a star. This is the amount. So if you find a process that resembles a star, it means that you have some form of synchronous communication in your calculus. And we basically show, no, that's not the case, you don't find that, and that's way more fundamental. Because this star pattern really represents the minimal amount of what you should see if you have any kind of synchronous communication in the calculus. Why this is the case is another paper, it takes way more time to explain, just bear with me here, or go into the intuition that we derive from that result. But the idea is you have a state, from that you have 5 different possibilities to go on, A, B, C, D, E, and in the picture, you see that there are neighboring steps like A and B, for instance, and they have to be in conflict. So neighboring steps, A and B, B and C, C and D, and so on, are in conflict, but everything that is not in conflict has to be distributable, so that means completely independent. So if A happens, there's nothing that prevents C from happening later, because A and C are not neighboring. They're completely independent. Okay, again, we find that in the pi calculus, right? That's a star. Easy, I mean, the A action is between these two things, and it's conflict to the B action because it requires this input here, which is removed by doing the step on the A channel, right? But the C channel requires these 2 choices to reduce the A. These 2 choices, they are not related, they are distributable. Right? That's the idea. Okay, so why do you not have stars in the mixed sessions then? So this is basically what you have to prove. The proof idea is very simple. If you have a calculus that has stars, you cannot encode it into, via respecting distributability, into a calculus that does not have stars. That's another result that we are really using here, that we do not really have to reprove. And so it suffices to show that there are no stars in the mixed sessions, and therefore assume there is a star with these 5 steps. So that means then in session types and mixed sessions, it means that there are always for every step 2 choices that interact. So every of these steps has 2 choices. And since neighboring choices have to be, neighboring steps have to be in conflict, they have to compete for a choice. And then if you repeat this argument, you really get a structure that needs to look like that, right? You have an A using 2 choices, the B is competing for one of the choices, and another one, it competes with C, and so on and so on. But now the problem is that this is not possible because you need, for one step, you need 2 choices on different session endpoints. So that one is on X, and that one has to be on Y. But for that step to happen, then this one needs to be on X again. For that step, this one has to be on Y. Then for that step, this has to be on X, but then these 2 are on X, so E cannot be a step. Because E cannot reduce 2 choices on channel point X. It needs an X and a Y. And it's not possible to close any cycle of Oct degree this way. So you don't find stars. And here the reason is the semantics. You don't find the stars because a channel endpoint can interact only with one other channel endpoint. Right? That's why you don't find them. Okay, so to sum up this part, you cannot solve leader election in symmetric networks of Oct degree. You cannot express the pattern star. What you can do, you can express the pattern M. That's the one for the asynchronous communication. That's easily to be found. I did not show that it's in the paper. And from these things, we conclude that there is no synchronous expressive power in this calculus. Right? So it's a corollary, of course. Right? Because there is no formal definition of what is the minimal amount of synchronous communication that you find, but it's really good reasons to say that there is not more. There is even one more thing. There is, in the original paper, an encoding from the mixed sessions into the calculus without the mixed session, with only a separate choice. And this encoding is good, and it's distributability preserving. So if this calculus had anything more in terms of expressive power, there could not be such an encoding. Right? So it really does not add anything. And we also learn one more thing from this encoding, namely that the difference between inputs and outputs in these choices can be captured by just labels in the encoding. Right? So it's really not more expressive power. Okay, so I promised you that next we would look into a semantics with Q for CMU+, which is not easy. So the named way to do that is, of course, first to add Qs to the system. So Q is just guided Q from one channel endpoint to the other. So we have 2 Qs for each session and 1 in each direction. And you can add messages, label, and the value that is transmitted to the Q. Now what you do is you change the semantics, saying that if you have an output and a Q, then you put the output on the Q and reduce the process. And the matching rule for input then, so you split input and output into rules, right? Is if you have a Q with an output message on top, and you have a matching receiver matching for the label, and of course for the channel, then you can reduce, and by that, the Q gets shorter, right? But that's not working, because it introduces deadlocks and new behaviors, right? Very easy. If you just look at these two choices that are combined here, what can happen is that both push their output to the Q, and then what happens is they both reduce to their continuation as 1 and as 3. So either you get new behavior, or the messages on the Q block everything, or there is simply nothing left to do. But it's not what is happening in the original term. Right? So this is not working, so how do you do that? Therefore, we look at the encoding that is given. I told you that there is an encoding in the original paper between mixed sessions and non-mixed sessions. And the idea of this encoding is the following. If you have, again, the term that you have seen in the beginning, the idea is to do the information about input and output into the label. So you can see there's an output blue on the top, and it becomes a label with a question mark here. And the green input becomes a label with an output, with a bang in the encoding. And for the orange output, it becomes an output label. And for the red input, it becomes a red input label. And that's why it works. So there's also some duality in the encoding. And now the question is, where comes the duality from? In the choices, you don't see which of them are external and internal, but the type system still requires them to be internal or external, and that always one internal is combined with an external one. So the type system gives you a type only for this, if you have that. And then from the type, being either external or internal, so the one on the left was the, oh, I forgot. So one is the external, the other one is the internal. And for one you switch inputs to outputs, and for the other one you keep them, and that's why the encoding is working. Okay, so the important part here is not how you deal with the labels, or that this encoding is working. It's not so trivial, you have to look into the paper. But the important point here is that the encoding uses the fact that one of the choices is external and the other one has to be internal. That's the important bit here, and we make use of that by putting this information back into the syntax. Right? We do, again, have 2 choices. They are both mixed, but one is external mixed, and the other one is internal mixed. And this that we can give a Q semantics, because what you do now is, if you have internal output, then you just do what you are supposed to do, right? You put it on the Q and do the continuation. And the matching input then has to be, of course, external. So you have external input, you read from the Q as expected. But for the other way around, you have to do something clever. And this is, if you have an input, and really you have to start with the external. You always have to start with the external. The external is what's wrong, sorry, with the internal. The internal is always the one that decides. So the plus is the internal, sorry. You have to start with the internal, and if the internal decides he wants to receive, it just does not do the reception because there's no output yet there, right? but it already reduces to this one part and becomes an external choice, and moves the thing, the label, as a message to the queue, just saying, I want to receive. I decided I want to receive next on L. And then, if you have a matching output on an external choice, this can consume this message in order to push the output on the queue. But an external choice is not allowed to push an output to the queue unless it finds this kind of message. And then you can again use this rule afterwards to receive it, and then you're fine. That's the idea. Okay, we did not prove that completely, but we are pretty sure that it is working like that. Maybe you have to do some small adaptations, but yeah, we are pretty sure that it's working like that. So what do we have? It's the last slide. There's an asynchronous semantic for the mixed sessions with queues, which is, by the way, very interesting, because for the asynchronous calculus, what you find is only backs, not queues, explicitly not queues. So for all the session type calculi that we know, even binary, what we find is queues, not backs. So already we do have asynchronous communication, but it's not the same as in the asynchronous pi calculus. It's a more guided form of asynchronous communication. It's nice, just a side remark. And this is, of course, what we also find here. And we have this result saying that this particular calculus, even though it syntactically has a mixed sessions, does not increase the expressive power. And what is the important part is, why is this the case? And we see that in this case, it's about syntax and semantics. It's not types. We do not use any types in this proof. It's not the type system that prevents them from reaching more expressive power. But of course, the types are somehow behind that, because they forced, I guess they had the way the syntax and semantics was built in order to make the type checking easy, right? And the main problem was, of course, that you still have external and internal choices. So if you want to add binary session types, really more expressive power, the expressive power of synchronous communication, at least a little bit of that, you would need to somehow divide from that. Because as long as you don't do that, there will always be a way to more or less get the same kind of asynchronous semantics with queues.
Because we can encode it.
Yeah, and so it's not really, you don't reach. So you really have to break with this intuition of having an external and an internal choice. It's not allowed that only one decides. If you have only one who decides what's happened to the XP next, and not both of them who concurrently decide or something like that, then you don't really get the additional expressive power. And important here, it's not a type system that prevents them, and is, of course, helps us to do that additional bit of expressive power with other calculi. In particular, with maybe this multi-party session type, some things might be easier because you don't have the duality. You don't really need to distinguish into external and internal choices. You don't have duality. From the syntactical point of view and semantical point of view, you don't have the restriction that you have a choice with only one other communication partner. They're already calculating that right that, right? So there you maybe reach the additional expressive power more easily.
Okay, I should add one remark. Original Honda Basque both calculus, if we add mixed choice to the shared name, then we can encode, because it has the same expressive power as pi calculus. We can encode this synchronization. The problem is your mixed
the double
session
pointer.
have two endpoints restricted, so that we cannot represent.
Yeah, the double binder in this case makes already the unrestricted part not having the synchronous power.
Okay, thank you. We'll take some time for questions.
Just a quick question. I mean, am I allowed to say that it's not fully asynchronous? Because in the case where you need to ask, saying I want to do an input and put it in the queue, you are kind of introducing a synchronization there.
Exactly, and it's also the point is that for asynchronous communication, you expect the output to be non-blocking, and that's not entirely true because it's an internal choice, right? have to wait for the decision of the other ones. But then you can push your output before this is received. So the actual sending action is not blocking. It's
so
debatable.
This is really work in progress. I think we have a better encoding if bounded, because Milner has encoding of bounded buffer using synchronous one. And this probably can give more flexibility, but we didn't have time to try that way. Yes, with Milner. Synchrony and asynchrony. He has argument synchronous mixed choice can represent asynchronous behavior using buffered encoding. If we can do this, probably bounded. But probably we can do better, not this kind of one. But we didn't have time to do that.
Okay, let's thank the speaker again. Okay, so the second talk in the session is on classical processes in modern dress.
What do I do? Okay. So 20 minutes. I don't know. Okay. And questions, including questions. Okay. All right. Sorry. Yes, that's my night mode. It's my night shift. Sorry. Night shift. Okay. Sorry. Right. Should be landscape mode. Okay. All right. Hello. Hello. Hi. I'm Vikraman. I'm at the University of Glasgow as a postdoc with Simon, and I'll tell you about some new ideas that I've been discussing with Simon about semantics of session types. And I should say that I'm an outsider to concurrency and session types. So I come from a background in type theory and category theory, like in the normal functional style. And so I've been trying to understand session types better using things that I know about. And so this talk is about things that are very much work in progress. And I'll tell you about some things that I think are important or important gaps in the theory of session types and how these could be fixed. And so let me start by so the title of this talk is Classical Processes in Modern Dress. And I picked up the title from a paper of Martin Hyland, which is Classical Lambda Calculus in Modern Dress. And it's a very nice expository paper which explains what, like at least in the last 30 years, what has happened in basic foundations of lambda calculus. And even though like we often think about just lambda as a binding operator, which hasn't changed much for a long time, there are many tools and frameworks for thinking about these kinds of type theories and binding operators. And so there's a lot of modern technology in in functional programming, or at least in simply typed and dependently typed type theories. And it seems that so these questions are quite hard when you go to linear logic and linear lambda calculi, and in session types it's even harder. So I tried to not go into the state of the art in these techniques, but just show you a little bit of what these kinds of tools can give you. So can session types be done in these frameworks? And we've been exploring, but so far I don't know if it's going to go, and if there's some big thing that we are going to find out at the end. So let me just continue. Just to start, I want to give a bit of motivation about why would you want to think about foundations of programming in a different way. So generally, like if I were giving this talk as a programmer, and you asked me what is a program, and then I would just say it's a string of symbols and it's a bunch of instructions that you give to a computer, which is usually a machine. And then so what exactly is a computer? It's a physical device. It has some notion of computation. But as programming language theorists, we completely ignore all the physical notions and take an approximate notion, which is to say that there are programs, they are abstract syntax trees, and the notion of computation is just reduction of programs, right? And so, of course, there are many languages, and they have different abstract syntax, and programs may reduce, may or may not reduce, and they might keep reducing. And as the user of a program, you're looking to plug in an input and wait for an output, and you want some notion of normal form for these programs, right? So this view of programs is an approximation of this physical process, which we think of as computation, right? Okay. So the same thing could be said about processes, right? So what is a process? It's a program or some other metaphysical notion, which so in session types we care about message passing and programs interacting with programs, and so again these are physical notions. Okay, but when we go to type systems, right? So this, I think, so going back to John Reynolds, who used this terminology of the difference between Curry style and church style. So in extrinsic typing, you have programs like the untyped lambda calculus programs, and you realize that they're not all well behaved. And as a programmer, I want to say that my program should follow some specification, or it's a predicate on my programs. And this, so when we take that view of programs, so types are an afterthought. So I write my program first, and then I give it a type, and then as a PL theorist, when we design languages, we think about reductions and whether the program you started with has the same specification after reduction. Okay, and this is very well known that there are good notions of what types should be, and if you set up your typing rules and reductions correctly, you get some well-behaved notion of normal form. Okay, so that's a very old view, or I mean, I know that both of them exist right now, but so then there's the other view, which is intrinsic typing, which says that, okay, so there are no untyped terms because you shouldn't be able to write untyped terms, because the only programs which make sense are the ones which have types. And if you take that intrinsic view of typing, then terms are typed, reductions are typed, and every term, because it has a type, we should be able to ask whether it has a normal form. So the notion of normal form changes a little bit, but essentially it'll be something of the same type which doesn't reduce any further. Okay. So this is great, but we're still talking about reductions and programs with normal forms. So, but there's also the other point of view, which is which started, actually way before operational semantics was there, because the field of programming languages started with denotational semantics, and then the point of view was that programs are strings of text, but they are actually mathematical objects. And when you think about mathematical objects, you don't think about physical construction. So when I say what is a function, I don't have to say it's a lambda term. A function is a binary relation which is well defined in total. It's a basic axiom of ZFC from which I can define functions. So the primitive notion of programs as mathematical objects is, I think, the purest that you can say, like, okay, so programs have to be some sort of mathematical object, and when you write down programs that have a type, they classify some sort of mathematical structure, okay? So this is sort of the intrinsic point of view, which is to say that every well-typed program you write is denoting some mathematical object, and that's where denotational semantics comes in. And to be able to say that, okay, my programming language exactly classifies all the, let's say, computable functions or functions which consume finite amount of memory. So these kinds of expressivity properties are things that type theories give you, okay? And it's not just, so I mean, in this community, we all know about, Curry-Howard things. So another point of view is that, okay, when I'm writing a program, I'm performing a logical deduction in some system. So when I'm writing in this presentation of the simply typed lambda calculus, I'm actually writing a natural deduction proof. And so that's the Curry-Howard view. But they don't have to be just proofs. So there's the whole field of denotational semantics is to assign meaning to programs which are not proofs or programs and mathematical objects outside this universe. So the simplest semantics for simply typed lambda calculus is that types are sets and programs are functions. So if I write a lambda term, a to b, the meaning of this type a to b, it's exactly the set of functions from the meaning of a to the meaning of b. And so sets and functions are, in some way, the most primitive objects in programs or functional programming. And it's not just one model. There are many models of the lambda calculus, and there are recipes to generate these models, which is what this talk is about. If you go back to early domain theory, there's the whole denotational semantics of PCF using domains and continuous functions. I mentioned this weighted relations model because it comes from linear logic. So if you have a model of linear logic, you can build a model of the lambda calculus and things like that. So this is a different perspective on programming. And now, if I wanted to talk about the simply typed lambda calculus, the simplest thing to do would be to write a presentation of the simply typed lambda calculus. So usually, all these presentations more or less follow this schema where you have types and terms and equations or reductions, right? Okay, so I tried to write like a relatively good presentation of STLC. So you have types, and you have judgments which tell you what the well-typed terms are, and judgments which tell you what the equations are. So when you write the terms, you say that gamma derives E1 of A, E2 of B, and then you can form pairs which have the product type and lambdas which have the function type. Okay, and then the things you care about are things like weakening and substitution. And once you have these good properties, you can write down an equational theory which has beta-eta equations. So the beta equation is where computation sort of happens, where you substitute values for expressions and reduce one step. And then there are eta rules, which also can be seen as reductions and sometimes not. But so the lambda calculus, as presented like this, is okay. It's a huge thing to write, right? But there's a very simple way of saying what the STLC is, and these are facts that have been known since the 70s, like Lambeck and Scott's categorical logic book. So STLC classifies the theory of lambda calculus classifies the theory of Cartesian closed categories. So now I'm going to use some category theory, but I'm not going to talk much about concrete categories or anything. I'll just vaguely tell you what Cartesian closed categories are. So Cartesian closed categories have objects and morphisms, and Cartesian closed means you add some more structure, which is just enough to interpret the lambda calculus. Okay, so you add the unit type 1 and times and functions, and the essential feature of a Cartesian closed category is this closure property, which is an adjunction which says exactly these three. So this is in logic where you say if you assume A and prove B, then you can prove the implication A implies B. This is like the deduction theorem from proof theory. Okay, and then if you are writing a term language, which is the lambda calculus, you write a lambda term for this function type. Okay, and if you are working in a Cartesian closed category, you just replace all of that with gamma times A, arrow B. So arrows are arrows in the category. So gamma times A is an object, B is an object, and the currying adjunction, it says that whenever you have this, and you can go from a program like that to a program like that, and the other way. So each of these rules are reversible, right? You can go from top to bottom or bottom to top, okay? And so this correspondence that I'm saying, it's a correspondence in a very technical sense, as in so we know about the Curry-Howard correspondence, which is that if gamma derives A, then there should be a lambda term, gamma derives E of type A, and if I have E of type A, I should be able to get a proof. And this correspondence extends to categories. So you have logic, you have programming, and you have programming languages or type theories, and you have categories. So what happens is, so you have propositions as types as objects, and proofs as programs as arrows, okay? And so categories go even one more level higher, which is, so we normally stop with Curry-Howard at types and terms, but when we go to categories, we can talk about whether two arrows are equal. So when you say that two lambda terms are equal in the lambda calculus, which means up to the beta-eta equations, you can show that they exactly show that the interpretation of these lambda terms as arrows are going to be equal in the category. Okay, and this is not just one way; it goes the other way. So if two arrows in this, so you interpret two programs, and if they're equal in the category, then there must be an equation in the lambda calculus which will prove the fact that these two terms are equal. Okay, so this is very, very old, and it has been known for a very long time, and this is sort of the simplest Curry-Howard Lambic correspondence, because it is very crisp. Like so, if just to give you a taste of how much further this correspondence has changed, because using more modern tools, what we can say is that we have a presentation of the free Cartesian closed category on some set of base types. Okay, so any presentation of lambda calculus that you write is going to satisfy this property that whenever you have some Cartesian closed category which interprets the base types, there's a unique way to extend this to an interpretation of the lambda calculus in C. Okay, and so this interpretation is it's not just a function on terms. It's a functor, which means it actually preserves equations. So when we do things like translations, we are actually, when we are translating the lambda calculus into some other language, preserving beta-eta equations, we are actually constructing a CCC functor. And so this is a very fundamental property. And further, the lambda calculus has a very much more interesting completeness theorem, which says that if it's any Cartesian closed category, it could be sets or any other Cartesian closed category, as long as it's not degenerate, this interpretation will, if two terms are equal in the model, they will have to be equal in the language. And this goes back to like 1950s Harvey-Friedman's completeness properties, and these are more or less like a modern presentation of old ideas. Okay, so this is great, but what can you do with this? Well, there are many meta-theoretic properties of the lambda calculus that fall out of just this basic fact. And these facts have been, so if you had to show that lambda calculus has normal forms or strong normalization, you have to give it a reduction semantics and prove Church-Rosser by doing very complicated induction. But these tools give you a reduction-free way of proving important normalization results. Okay, and the fact is that the other fact is that sets and functions are, because it's Cartesian closed, it's a very fundamental structure for functional programming. Okay, so I wanted to say, so I've been talking about lambda calculus, but there are many other languages, and many people have been thinking about categorical semantics for their languages, and there's a very long list, and I wanted to just point out that people normally talk about lambda calculus, and then there's polymorphic lambda calculus, which has lambic correspondence and Martin-Löf type theory and toposes. If you care about programming, so call by value lambda calculi, as Eugenio Moggi showed that a strong monad can axiomatize it. I wanted to also mention S4 modal logic, which Frank Fenning worked on, and it also has an axiomatic semantics using monadal comonads. So where do session types come in? And that's the question I wish to explore. So all of these languages, like they sort of have a Cartesian flavor. The substructural rules don't change much. But when we go to linear logic and linear lambda calculus, the situation is much more complicated on the rightmost side. So if I took the linear lambda calculus, which I'm calling intuitionistic linear logic, so it's just with tensor and a lolly, and this can be shown to be in correspondence with symmetric monadal closed categories. Okay, and so I mean there are many variants of linear logic, and some of them have categorical semantics. So MLL, which is MLL without negation, it only has tensor and power, and there's an axiomatization in linearly distributive categories. And then there's linear nonlinear logic, which I think that DIL is a term model for LNL, and it should correspond to LNL models. And then classical linear logic by Curry-Howard has been shown to correspond to classical processes or hypersequent classical processes, and they should have something on the right. So what is the right structure to capture session types? There was the famous the proofs as processes program by Abramsky, which people started thinking about it a lot, and so there is a lot of work by people, and everyone had a different opinion on what the right language for concurrency should be. So before session types were invented or were mainstream, I think, so people were trying to take the pi calculus and find a correspondence with linear logic, and so Bellin and Scott was one of the important ones, and I think. So Abramsky and Simon and Nagarajan, they came up with interaction categories and specification structures, which are a term language for linear logic with the semantics. And sure, so and people have tried to find correspondence between proof nets and pi calculus, and the other very important work in the pi calculus was by Sangiorgi and Fiore, where they showed that if you take pi calculus and tweak the bisimulation relation, you can get a fully abstract model. So set to the I is a perfectly fine model for the pi calculus, and it's a completely mathematical model. Okay. And in session types, the Curry-Howard program started with Karj and Fenning, and then Wadler did it for classical processes, and CP has been extended by various other people, and I think the most recent one is by Wen Koka and others. people have also been thinking about denotational semantics for these systems, and I think one of the first papers was by Bob Atke on where he used a relational model to explain CP. Okay, so, and also Ryan Kavanagh's work and various others, which I tried to mention. Okay, so I'll just quickly, if you haven't seen CP, because it's a very, like a very simple calculus in which you never want to write programs, but it's just a term model for a presentation of linear logic. So you have different kinds of types for tensor and par and coproducts and products, and you have a duality relation on types. And then there's a judgment which says a process in context gamma is generated by these rules, and so the simplest rules are usually axiom and cut, which says you can create XA and a dual, and cut, which allows you to put two processes. Okay, so I think that should be a dual, not B. But so when two things are dual, you can put them next to each other. Okay, and then there's sending and receiving using tensor and par, and this is normally how the system is set up. So this is a presentation, and what does it mean in terms of categorical semantics? So more or less the key idea that after reading a lot of papers on session types and trying to understand what exactly is the common thing between each of these typing rules, more or less my intuition is that so in lambda calculus, functions are we create functions by lambda abstraction, but when you add duality, this function type splits into two things, and in fact, so you add a duality operation on types, which allows you to type things which are A and A dual, and okay, so I mean it's a string of symbols in categorical notation, but what it means is that these two junctions are very fundamental to session types, or I think so. So let me if you want to know what exactly is the model, so this is sort of the model which I think works for most systems of session types. So you take a category which can interpret your tensor products and your pars, and then you add a duality involution which splits your types into two things, okay? Into two adjunctions which allow you to make these processes interact. And so what happens in CP, so I'll just show you, for example, two different rules. So you have a process in type gamma, and this exactly gives you an arrow from 1 to gamma. And so if gamma has x1, A1, x2, A2, it's interpreted as a tensor of all these things. And so each rule has an interpretation, and just from these few basic facts, you can build all the structure of CP. And it involves some algebraic manipulations using adjunctions, but the point is that finally you get a theorem which says if P is a well-typed process, then you get an arrow from 1 to gamma, and this is built up compositionally by combining the semantics of each type constructor and term constructor. And well, if you add choice and branching, and so that corresponds to coproducts and products. Okay, so the last few minutes I just want to say, so okay, this is great, but it stops at types and terms, and what about reductions? So it seems to me that there is, I think other people have mentioned as also that so there is a lack of a typed equational theory in CP. Okay, so in CP, there's even a worse problem, which is that the reductions are on configurations, not processes. And what would be a typed bisimulation or a typed or a judgmental presentation of what two processes being equal should be? Okay, so going from CP, so CP has a bunch of problems, and HCP comes and fixes it. So for example, CP requires you to put two processes next to each other as a term. But so in HCP, you don't have to do that because now you have this double binder, which allows you to put to cut between X and Y in two different environments. So HCP has this notion of environments and hyperenvironments, and so CP can be improved, the presentation can be improved, and so it's not important how much the typing rules change, but the same kind of soundness theorem also holds for HCP. And now HCP has a notion of bisimulation. So the recipe for writing bisimulation in these session-typed languages is you just forget the types and go back to PyCalculus and use PyCalculus rules, right? So if you try to reconstruct these label transition systems using types, you notice that it's only the tau transitions that preserve types. And in fact, so the semantics that I showed you, it allows you to prove that if you have a tau transition and it's on some hyperenvironment G, then they produce equal arrows in G. Okay, so I don't know if this can be improved, but what about the non-tau transitions? I know there's some work in progress by some people. I'd love to know more about it. Okay, so just to summarize what all this means, so I'm claiming that there is a family of models for these languages, and any category where you can find this axiomatic structure is going to be a sound model for this language. So the simplest model is the category of sets and relations, and if you instantiate the semantics, you recover Bob-Atkins semantics. If you like geometry of interaction, so if you instantiate geometry of interaction on the category of CPOs, it becomes a compact closed category which also has this structure, and this recovers Ryan Kavanagh's domain semantics for CP. But both of these models are actually degenerate. They don't tell you much about what's actually concurrent. So there are better models where this structure exists, and so these are quite technical to explain, but maybe many of you might know about event structures. So there are many variations on event structures, and you can look at them as games. So if you take concurrent games and winning strategies, that also has this sort of structure. So this gives you an interpretation in event structures. Okay, and once you have a model, there are many different things you can do. So either you can extend, so you could ask the right questions about syntax, but by looking into the model. So for example, the fact that these two ends are different, well, it's a fact about star autonomous categories, like not all of them have to be the same. Or you could characterize process equivalence by looking in the model and trying to see which processes are equal, and then trying to extend your syntax for equations to fit that notion of equivalence. Or you could just go to the model and say that two programs are equal if they're equal in the model. So for example, in event structures, if you have two processes interpreting event structures, they'll be equal if they have the same causal history. Okay? And there are many other things which could be interesting, like understanding deadlock freedom more semantically and understanding these translations and other extensions using, yeah. So I'll stop here, so this is the goal of the project, and we hit many problems, and I'd be interested in feedback or advice. Thank you.
Let's take some time for questions.
Thank you. Can you repeat what you mean the problems of CP? I mean in your undertaking you identified like there are a few problems in CP. What are those problems exactly? Can you repeat?
Where are the problems?
Yeah.
Yeah.
You said something like reductions and
yes.
operations are not processes.
Right. So
Something like that.
That's.
Yeah. So in CP the reductions, you have to define configurations and define reductions on configurations. So it's not a reduction on processes.
But are you referring to this work by Bob Atke,
Okay,
given
before,
the
like,
notational semantics for CP?
Yeah, okay,
Is
but
that what
also
you have in
before
mind?
that, like Wadler's presentation, right? Or Lindley and Morris.
No, I mean for the PyCalculus you have a reduction semantics. You don't have configurations by themselves. So
okay, but
so that's the part I don't get.
Okay, so I mean CP is a language for just a term language for linear logic, right? So and then you can put you know, two processes next to each other, and then you want to have shared channels between two different processes which are not next to each other. And for that, I believe you have to define configurations, is how I understand it.
Okay. So this is your, okay, so you're inferring that in order to have these unit configurations, because that's not
Yes.
part of the actual paper, right? So that's the part that
Right.
was confusing me.
Yes, and I mean, I think that there's a way around all this, which is like what HCP does, where you just add hyper environments and.
I think I'm sorry. I think
Okay.
HPC, what it adds basically, it has a stronger correspondence to the PyCalculus because
Okay,
like
yep.
in CP, for example, you combine name restriction and process spawning.
Yeah, in the typing rule.
Right. That's one thing. But HPC has restriction and parallel composition separates the two.
Yeah, which is what the I think I wrote the mix rule.
Contribution, among other things.
Yeah, so it splits the normal cut into cut and mix.
Yes, exactly. So mix is just parallel composition, but you don't share a name yet, or you
Yes.
don't
Right.
share a channel yet. And they use hyper sequence in order to ensure that it's still develop free.
Yeah.
So, yeah, okay, I'm sorry to.
Yes, I mean, I don't know what is the best presentation of CP, which will have a typed reduction. And
I was actually wondering when you said that the problems, because I think CP actually, if I'm not mistaken, reductions do not preserve well. Oh, I'm sorry.
Yeah, I think so that in CP you don't get under reductions. So the processes do not remain well typed.
They do. I mean, on the transitions they're not well typed, but they're not supposed to preserve transition, right?
Well, I'm blanking right now, but there's the paper by Ornella and others at Concur, I think last year. So Ornella's not listening.
I'm not looking, but I'm listening.
Right, where you introduce the trees so that you remain well typed. The reductions mean, oh no, sorry, it's structural congruencies.
That's what breaks.
Right, that's what breaks exactly in CP. Yeah, yeah. Structural congruency is doesn't preserve well typeness. And I guess
I think there's a subtle point, because if you take the untyped structural congruence, of course, it's not preserved. The point is that there is a notion of structural congruence that can be recovered from the convenient conversions in the logic, right? So that's how it will come kind of automatically.
Yes. But in your work as well, you preserved it.
Yeah, because we were a bit more like detailed in doing that. Yes.
Right.
Yeah, sure.
Okay.
Sorry about that.
Okay, I'd be curious to know more about what it is. Yeah.
Okay, I just have one quick question. Yes. So in your categorical semantics notice, you didn't talk about the exponential.
Yes.
Does that fit into this, into
Right,
the whole
so
picture?
adding exponentials to the CP syntax, I just know one presentation, but yes, it does fit into this framework, yeah. So the way you do it in a LNL model by adding another adjunction.
Yeah, in LNL I know how it works, but
Yes.
we're talking about the star autonomous categories and
Right.
other stuff, and you didn't mention the exponential.
I do know how to do it. I just don't know how to apply it to like an actual presentation of CP with exponentials.
Okay.
So in the semantics it does work, but I don't know about the syntax yet. That's it.
Okay, well, let's thank the speaker again.
you want to mirror the screen to have the same thing there? Or you prefer to move these and have...
Let's mirror them.
Okay, let's mirror. Settings. I think it's screen display. Mirror. Apply. Keep changes. It died. Eccolo. Here we are. Close. And
Perfect. Thank you.
no worries.
Oh, yeah, there is a typo. Lorenzo, where is there is a typo. Where is the thing you gave? No, it's in my myself. Do you know where it is stored?
Yes, is it's fine. I mean,
we have enough time to fix it.
There's nothing interesting or secret on this lab, so.
Yes, and there I can finish.
Yeah.
Thank you.
So welcome to this last technical session of ST30. We start with Martin Wasser presenting work with Nobuko as well, and a call to the community. Let's hear it. Thank you.
Yes, thank you. So yes, as you just said, this is a call to the community because it's not even a side project, but more an idea that we have, and we want to build or to gather some protocols, some standard things that we usually see in MPST, and to make something of like that would look like a benchmark, but not in the same sense as the benchmark Lorenzo presented yesterday. And as I will, sorry, with the same laptop, but a different project. And yes, I will try to convince you that this needs to be something that is led by the community and that I cannot do alone, we cannot do in a single team, but it would be helpful to have like feedback from everybody. And so that's why I think here was a good place to present you this. Before starting, I would say I'm very glad that many of you presented before, so I could shorten a lot of the slides I prepared, and so hopefully we'll have a bit more time for the discussion. The main starting point for this idea is that, well, when we look at session types, we have a lot of different implementation, and here I cite just 4 of them, and those are only implementation in Rust, which is just one programming language amongst many others. And it is just to illustrate that there are many of them, and they are not the same. Like Sesh, for instance, is for binary session. If I'm not mistaken, Multicrust is for synchronous session. And so they are alike, but kind of different. And as we had a very nice talk yesterday about different expressiveness for different variants of session types, well, we also have to accommodate for all those possibilities that exist. And so the main point is how do we compare those things from more of an implementation viewpoint. When we are writing papers, often we have the following pattern. We think something is missing, we present an extension for session types, and we argue that this new extension is useful with respect to what we mentioned was missing. We propose an implementation, or we adapt an existing implementation, and then we evaluate the improvement of the things we add or the overhead if we have some new feature. And among those 4 different points, well, my question is how do we address those 2 points? And arguing for the usefulness of an extension is fairly easy. We find an example. We say, well, this example is difficult to implement using what exists already, and so we would like to address this example. Evaluating the improvement or evaluating the performance of a modified implementation is a bit more tricky, because if we focus only on the example that motivates our extensions, then we risk to be cherry picking what we evaluate. And so usually we would like to do that with carefully chosen protocols, so things that we recognize in the community are important for us in general. And as I just said, how do we do that without cherry picking? Well, we need to agree on something that makes sense. And so this is kind of the goal that I would like to share with you today. And it's an open question, and which is what set of protocol would represent overall the needs of the community. And I'm very glad yesterday, Nobuko, in your future work or future direction, you had this small line about benchmarks, and here I think we can relate to this. So what are the main difficulties I identified so far? So the main one, obviously, is to address or to have a meaningful set of protocols. And what I mean by that is, on my own or in the emerging team, we can like say, oh, we think this and that is important. If we look at other papers, we can identify patterns that occur frequently, but we are always at the risk of missing something. And so that's why we are all together. So I think it's a good moment for everybody to say, oh, I want this to be included, I want that to be included. And in particular, one of the other main points that I think is important is that we need to address a lot of variants of MPST or a lot of different implementation of MPST, and we have to keep that in mind, not to pick something for a specific implementation. So before I continue here, if you want to have a look at what we have so far, feel free to go. It's online. And thank you. And I will just briefly describe now what you can find on this repository. So to address that, I will explain what was the way I view that, and obviously it's open for criticism if you think we should do something differently. And from an individual viewpoint, I think the best I can do for gathering a meaningful set of protocols is to look at what exists already in the literature. And sometimes, I mean, even that is not necessarily a trivial task, because sometimes we have the same protocols that are actually renamed between different papers, or sometimes we have protocols that are very similar or that exhibit similar constraints or requirements, and maybe it would be interesting to have, say, one canonic protocol for each of those classes. And to address various MPST implementations, here we have, I think, two sides of this coin. The first side is, well, if we try to explain to people that are not necessarily part of the community what we are doing, I think it's important to kind of document what is in this benchmark. And so there is, for each of the protocols that I will present in the next slides, there is a PDF that you can take. You can copy-paste the source, put it in your paper if you want. And that is hopefully readable even by someone that is not necessarily part of the community. The second side of the coin is if we want to address a benchmark for implementation or evaluating implementations of MPST, we have to somehow make those protocols available for a given implementation. And this is a bit tricky from a technical viewpoint because there is not a single canonic way to represent MPST for implementation. So we have the Scribble language, which is a possibility that is quite easy to parse and to put into actual implementation. So here I also provide, so not a Scribble, but a new Scribble, which is almost the same description of each protocol, and hopefully that can make it easier to use. I just want to have a quick word on what I consider as selection criteria, and this is where the controversial part begins, because I assume that we all have different opinions on what is important or not. But at least I think it's important to have both binary and multi-party protocol, because, I mean, there are implementations that are only binary, and we should not exclude those. Similarly, I'm very happy that yesterday we had a talk about reactive session, because at the end there was this question about choice, and maybe we can, how can we add choice? And this illustrates, in my opinion, that choice is not necessarily trivial, and so we can have protocols that have choice in them, protocols that don't have choice in them. Regarding recursion, I think you're all much more aware than I am about the difficulty of recursion, all the variants that exist, and how all the way it can be addressed. So similarly, we can have protocols that do have recursion, some that don't have that. And then the fourth point is a bit of an arbitrary one, but it's just to illustrate that maybe from specific features, such as dynamic connection or the creation of new participants, but it can be other things such as delegation or things like that. Maybe we can get protocols from papers with such feature and try to see how could we do something that would be similar or that would have something analogous in, say, normal or vanilla MPST. So those are the criterion I've thought so far. Obviously, if you have other ideas or if you want to argue that those are not meaningful, I'm very happy to hear your feedback. And as I said previously, so those are the way to categorize the protocols. Then when we do things, when we pick protocols, we have to keep in mind that maybe it's not, we should not try to reinvent the wheel, reuse existing protocols, as I said before. And also, if possible, when possible, we can try to have examples that are suitable for extensions, or if you have in mind that you may want in the near future to develop session type with that, and you already have an example or a motivating example for that, it makes sense to try to figure out and to put it in this set of protocols. So I won't enter into all the details, but this is what we have so far, and you can probably recognize some of the protocols that you often see in papers. For instance, the famous two buyers example or travel agency. Some of them are slightly modified. For instance, multiply and quit. I think it still comes from one paper. There is the reference in the repository online, but this is basically the most simplest thing you can have without recursion, without choice, and only binary. So it's very simple, but it's still important, I think, to have that. Now, if you go on the link I've given before, so you would find something that looks like that. And as I said, you have on the one hand the new Scribble source, and on the other hand the PDF sources. And so the new Scribble look like that. So if you are not familiar with Scribble, as you can see, it's pretty straightforward. And the point is, it's both easy to have or to import in your implementation. We already have quite good tooling. For instance, if you are not concerned about projection, there is a new Scribble tool that does the projection for you and gives you the local types or the automata of the participants. So this is why it's quite interesting to have that. And also, it's quite easy to extend if you want. There are ways to add annotations that makes it quite easy to parse if need be. On the other hand, as I said, we also have the documentation side of this benchmark. So for each of the protocol, you would have a file that looks like that. And as I said, the idea is to have something in standard MPST, and as you probably know, there is no standard MPST, but the idea is that someone that doesn't really know what is MPST or doesn't really know all the subtlety about that can come have a look at that and understand the main idea of, or have the core feature of that are frequently common in different variants. Also, I tried to each time to go back to the first time each example appeared in a paper. It's sometimes a bit difficult because maybe sometimes the chain of citation was broken or things like that. Again, if you see a mistake or something like that, just let me know. As I said, the source are provided, so it's also when you're writing a paper, instead of rewriting again and again the same thing, just copy-paste the thing. It's available, and it makes it fairly easy to have the examples in the papers. Sometimes examples, so this one is not the case, but sometimes examples were a bit slightly modified from their initial presentation for practical purposes. For instance, if it comes from a modified MPST or MPST with an extension, I tried to remove that extension and to have something equivalent. When it's the case, there is always an explanation that relates exactly what was done in that. Now you might be asking why I'm presenting this, because it's, as you can see, very much not technical, and it's very much a work in progress, but I think it's useful if you can come and say, well, you are missing this example that highlights this feature, and this does not appear yet in the set of protocols that you have. And in the end, if we want to use this set of protocols to reach a broader audience when we publish in conferences that are not necessarily focused on MPST, and we want to address people that are from programming language or even a wider audience, maybe I think it could be beneficial for the whole community if we had this set of protocols that we don't need to argue that each of them is meaningful. If we could just say, well, this set of protocol we agreed as a community as being something useful. Here it is, and take our word for that. And here is how we compare to existing things. And this is why I think your feedback is important for this work and for this work to continue. As this is work in progress, the main part is the future work. And here there are two different things. So on our side, and I'm willing to put a bit more work on that. So the main direction I can imagine are first, maybe providing a default implementation for reference. Here it's a bit tricky whether we should provide an implementation, whatever it is, even if it's not the most, say, up-to-date or state-of-the-art or more performant if you want, just to have something as a reference, or whether we want to have the current state-of-the-art implementation, and here we have to argue on what is the state-of-the-art one. On the others, another point that we can do is provide some tooling. So as I said, for instance, New Scribble also already comes with plenty of tools that makes our life easier, but I can think of other things. Typically, if we agree on a given set, maybe I can write a Docker file, then you just put your implementation in that and it runs all the benchmark for you and even maybe generate the tables that then are to be included in your papers. I don't know what makes sense for the community, but we can think of many things. And of course, on our side, the next point is insert your request here. So if you have ideas what we can do in here, let us know. I'm very happy to hear that. On your side now, what you could do if you think this is an interesting project. The first thing is using it, and using it in a broad sense. That is only, like, even if you are only interested in finding where an example comes from initially, and you just go on this repository and find the reference, this is already useful, in my opinion. If you want to have a deeper use of that and to actually use it for comparing your implementation or improving your implementation, this is even better, but there are many ways this could be used. The second point is criticize it. As I said, this is just from my viewpoint for now. We discussed that with Nobuko, but it's very limited, and we have a very different background, and I think if you come with criticism, that can only make the thing better overall. And finally, typically points of criticism is like, oh, if you think this doesn't fit your need for whatever reason, just let us know, and we can discuss that. Or I mentioned that previously, but also, for instance, the selection criteria, I'm very well aware that this is a bit arbitrary for now. You probably have good ideas, and I think it's good if you could, discuss with us. And finally, if you have a lot of time to devolve to that, you can also improve it. I mean, it's on GitHub. I'm very happy to give you access rights if you are interested in that. If you have any ideas to improve that, just drop an email. So that's the plan for now. This has the assumption that you find it useful. If as a community we don't think this is useful, I'm fine dropping it, but it might also be the opportunity to start this project. Yes, it's obviously a work in progress. And so I hope you have questions or remarks, but if you don't, I wrote 2 of them for you right now. So thank you very much.
Thank you for the talk and for the initiative. I think it's a very important contribution. Yes, please.
Hey, thanks for your talk. That sounds very nice. Maybe I have missed that, but do you only consider protocols that are positive in the sense that there are projections, or do you also consider like having some that are negative? Because other benchmark suites for SAT, for example, would have both kind of examples.
So I would say it depends. I mean, I'm open to everything, and I didn't think about what you just mentioned, and it makes a lot of sense. The initial starting point for me was to compare implementation, so they need to be projectable, but it would make it would make sense also if we want to go a bit more on the theory side and compare, for instance, implementation of projection, like typically new Scribble versus your favorite tool. We could totally include such kind of negative examples.
Do you think it would also be interesting for your repository to collect results of the benchmarks from particular systems and tools? So then instead of, if you want to see what has been achieved so far, you can look to the repository instead of searching for papers that are reporting the benchmarks for new tools?
Yes, I think it's, from a technical viewpoint, it's not necessarily very difficult to do. I mean, it's just a git push once in a while. The only thing that we have to be careful is if we cannot just take results from this paper and compare them with results from that paper, because they might come from different computers. But if a user of this benchmark is happy to share the source of their implementation, I can totally have a quick script that runs it on my computer and compare on, say, a fair basis for that. But it could totally be, included in that. And I don't think it requires that much work.
So this is a follow-up on Felix's question. So do you envisage also to suggest a list of open problems, so to say, or desirable practical protocols one would like to be able to model and which aren't currently handled?
Yes, this is a very good question, and it's difficult to do so if we look only at the protocols that are in the papers, because, well, often when we put protocols in our papers is to argue that we can solve them. But if, as a community, we say that, we would like to solve, for instance, or to implement this protocol, and so far we don't have a paper that do it, I think it makes total sense to include it as well. Then comes the question of whether we can explicitly mark it as an open problem, and this is where, in the documentation, the PDF side of the thing, it's very easy. It's, from a technical viewpoint, this is very basic, and we can totally add a line like this protocol so far cannot be implemented in the non-implementation of MPST or just session type. So yes, yes.
Thanks for the initiative. I think it's really an urgent need for people to understand, especially for people outside the community, you see, because sometimes even our own students, they try to understand things and it's hard to point them out. So in that direction, one particular experience I have had is that students, they don't know which papers, how to navigate the papers, right? And sometimes you have these examples, they come from specific papers, and the two-vendor example comes from many different papers in different flavors. So as a suggestion, but without trying to abuse of your initiative and free will, is to actually put some links to the papers and or to the DBLP entry or whatever, you see, because part of the difficulty of understanding these things is actually navigating the history and the connection between the different papers, because sometimes you have this paper that proposes something, then this is improved in a follow-up paper, then the protocol changes a bit, and so on. So collecting the examples is great. It's really a very, very important step. It will be nice also to have these connections with the DOI, for instance, of the paper where it was appeared.
Yes, and again, this is the strength of the community. I didn't really think at all about that. The point of having the citation was just to include the original one, but as you said, it makes total sense to also keep track of the link of citation. And again, this is work we have to do anyway when we want to go back to the original thing. It wouldn't take that much additional work to put it in as well.
Thanks very much for your talk. I know that you expressly are not concerned about the criteria right now, but I just wanted to ask a kind of question. If you go back to the list of examples that you had, it's not to focus on what you chose. I just noticed that a few of these came from some papers where it was session types plus refinements, let's say. I was wondering, did you keep the refinements in here, or?
So no, so some of them, like typically when it comes from session type with refinement, this is where I try to remove the refinement type, and so obviously we lose something, like we lose what we get from refinement. But the point was to have a motivating example and say, and then we can also argue like, with standard session types, you can only achieve that without having the guarantee, for instance, that the loop is bounded. And then if you do that with the refinement, you can have a bit more. But the point, yes, is to try to get rid of what is specific to each individual paper.
Thanks, that I think answered my question. And just to follow up what Jorge is saying, I think somewhere in this presentation you mentioned I cite the first one where it appears. You may as well cite them all, right? Just link all of them. There's no need to just record the first one. I think that'd be really helpful.
So this is, instead I think this is painful to do, but a feature that I would consider useful would be not removing features, so like for the refinements and stuff, and actually when, and ideally, okay, the database gets bigger, and then you implement in the website a search based on features and things. So I want to write a paper on refinements. No, that's the example, sorry. On refinements, I have the search saying refinements, and it shows me articles that are relevant to my criterion.
Yeah.
So I think this is definitely useful. I'm aware that this might be more difficult to maintain.
And I think here there is also a bit of what is the point. And I see two different directions, and they are not necessarily exclusive, and we can probably do both. But there is also, I think, this aspect of if we want to compare compare different evaluations of protocol, we should have, I think, a fixed set of protocols that we could say, well, we have those 15 protocols, for instance, that we consider are a basis for evaluation. And so if we want to address the largest possible amount of implementation, then we have to try to be agnostic of any specific features. Now, this is absolutely not exclusive with having this well-defined set of protocols, but also having as a reference, actually, this comes from this paper on refinement where it initially looked like that. And where, in this case, yes, we could have like a broader or more like a big wiki of protocol where we could just navigate the thing. Even if they are not part of, I mean, we would have then the collection of known protocols and the benchmark for evaluation. That would be two different things, but it's not necessarily exclusive. I think we can do both.
Yeah, so I agree. I think that's an amazing effort and really helpful for the session type community, because sometimes I think that if we try to publish in the larger PL community, then we're still a bit outsiders, and having a repository of benchmarks or examples, I think would be really helpful. I was wondering, did I understand correctly? Right now, it's the examples are Scribble-based?
Yes.
I see. But I guess probably, like, let's say if you wanted to include examples of binary or even like the different kinds of families of session types. So.
Yeah, this is where I think I put Scribble because it's the thing I know the best.
For sure.
And this is what I meant by this is very arbitrarily.
Right.
If you prefer to use another specification language, let me know. I mean, it takes time to encode things, but when it's done, it's done. And I think we can address, and the more input kinds or input standards we have, the better in the end.
I agree.
So we need to conclude this session, but for sure that after the break in the panel discussion, this probably will come up again, so we'll have an opportunity to continue. Just two quick suggestions. One is to organize with respect to properties, not only with respect to versions, but also that these protocols were proposed exactly to show that the system enjoys of this particular property. So that's an organization that I miss. And the second one is that in the program verification community, for a long time, there is this competition. And this competition is good not by itself, but for people to look to the benchmarks and to show their tool and compare in this competition the tool. And it gives visibility, it gives a criticism of an auto-criticism and a comparison with others. So maybe this year is too soon, but since this verification competition takes place usually with ETAPs, for 2025 we could think of organizing something, because typically the problems of the software verification competition are problems that are not suitable for behavioral types. And so if we have our own benchmark and we propose them like a track of that verification competition with our benchmarks or with our property-oriented problems, then this could give visibility as well. Thank you.
Thank you.
So Matthew is the next speaker. Exciting application of behavioral types or session types to consensus protocols, right?
Yep.
Let's hear about it.
Yes, yes. Thank you. Okay, brilliant. So, hello everyone, I am Matthew. I'm a PhD student at the University of Glasgow. I'm in my second year and I'm going to talk to you about the inspiration behind my PhD. And before I started the PhD, my master's was in a completely different field. I researched consensus algorithms in the perspective of distributed computing. And I was very interested in verification of these kinds of algorithms. And I was quite unsatisfied with the level of verification I could get through the methods I was looking at in my master's degree. And I decided to try and approach the problem from the side of behavioral types. And that's what inspired my PhD proposal. And the aim of this talk is to make everyone aware of why typing consensus algorithms is a bit tricky, the problems that can be addressed, the problems I'm trying to address, and just inspire some discussion and conversation around it is my aim. So Nobuko inspired me to add an extra slide in this, which I added yesterday, because she had a slide on SMTP, simple mail transfer protocol, right? And that was described in about 50 pages, I think you said on the... Yeah, okay. So consensus algorithms are quite notorious for being rather complex, so much so that they don't even have official descriptions, not even in English. If you want to try and figure out how one works, you have to look at the papers in which they're published. For instance, probably considered the first consensus algorithm, Paxos, designed by Leslie Lamport, was described in this paper, the part-time parliament. No one understood this, and so many more papers were published trying to make it more accessible and easy to understand so people can implement it correctly, after which people gave up and make a whole new consensus algorithm which tries to make things a bit more easy to understand. So there's, yes, people find a lot of difficulty in implementing these things correctly. And that is the aim of session types, right? We want to help people implement these complex protocols correctly. So I know everyone's familiar with what session types are, but maybe not everyone knows how consensus algorithms work, so I have a small demonstration. Well, a consensus algorithm works for distributed nodes, which are connected over some network, which can be prone to failure. And the aim of the consensus algorithm is to get these nodes to make group decisions, right? And typically, one node will propose some value. For instance, this node decides, I want to change color to red. And if one node proposes a value and everyone likes it and agrees with it, the consensus algorithm has a guarantee that some majority will agree to also change color to red. So one guarantee is we have this notion of safe replication. So if a decision is committed, then it should be on a majority of nodes. Well, why do we want this guarantee? It's to provide some amount of fault tolerance. Right? So if we have one node that goes down, well, if we query what is the color that was chosen, we should still get red, even though one node failed. Right? And so we have fault tolerance guarantees. And lastly, a very important guarantee is that if some node goes rogue and decides, okay, let me propose a new color, I want to propose blue, then it should not be able to override everyone else just on its own. So it should eventually come back to speed with the group decision, turn red, and so we have this idea of commit safety. That is, if some decision was made, then this decision should be made by everyone eventually. So this is what a consensus algorithm really is, right? But so why is it difficult to type? Why is it so hard to write session types for these kinds of protocols that are very meaningful, right? That describe a lot of interesting things about the protocol. And I wrote down some reasons as to why I have found it difficult myself. And the four most important points, I guess, are that many consensus algorithms rely on these things, right? So firstly, we have failure detection. So since the protocols are designed to be fault tolerant, the protocol is dependent on some kind of detection of failure, or some kind of assumption that it can make to say, oh, some failure happened, then I will change my protocol and do something else. Also, protocols are largely dependent on cluster size, so this will affect the design of the protocol, and making a session type agnostic of how many participants are in it is rather tricky. Also, commonly, there is a large dependency on payload values. So the protocol itself can change depending on specific values that are passed inside the messages. And lastly, probably the biggest point is that consensus algorithms have to employ non-deterministic behavior. There's a very common property inside a lot of distributed algorithms that these algorithms cannot be symmetrical without having non-determinism. So it's a must. We can't get around it. So my first attempt at trying to write session types for a consensus algorithm was at XIII 23, where I developed MagPi, which is a multi-party asynchronous and generalized pi calculus. And the idea of this was to develop a calculus and type system that can reason about failures. So for these 4 points that I mentioned over here, I was really addressing this failure detection and this non-determinism. And how does MagPy do this? Well, in our calculus, I just put down the interesting parts. In our calculus, we have an inbuilt notion of timeouts. So a timeout can be very powerful. Using a timeout, you can introduce non-deterministic behavior, and you can also use it as a method of assuming something went wrong. I haven't received my message because something went wrong, so I'll time out. I'll just briefly explain the syntax. From the left, C is a channel which you are using to receive. In this case, I only put the receives noted by the ampersand. We have undirected branching, which says you can see by quantification over the role Q. So we're saying using channel C, I will receive from some Q the message M, right, with payload values. And the interesting thing is the bottom one, where we can have a nice little clock, which denotes a timeout. And after there's a timeout process. And this is saying, well, if I non-deterministically time out, I could continue according to Q. And we reflect the same thing inside the session types in this page. So we have standard local types, as you would expect, with the, again, undirected branching for roles, so you can expect a message from different participants. And we have this clock again in our session type, which allows us to describe a failure handling branch. So in the case that some failure was assumed, then we can take this timeout branch and continue according to S prime. Okay, so using MagPy, oops, okay. Using MagPy, I set out to try and write a consensus algorithm, right? That was the aim of it. So I gave Raft a try. Raft is a consensus algorithm which was originally designed to be understandable to some extent, right? It provides fault tolerance for F nodes in a cluster of 2F plus 1. So that means as long as a simple majority of the nodes remain alive, we can assume all those assumptions I mentioned earlier. And how Raft works is that every single node runs its own state machine, and what the algorithm does is make sure that this state machine is replicated across the whole cluster. So, what I'm going to do now is give you a very brief demonstration of a subprotocol of this algorithm. Since it uses a leader election to decide the leader that will take decisions for the whole cluster, the leader election side of it is a very core part to the algorithm. And so I will demonstrate this, and we can see how can we type this leader election protocol in the consensus algorithm. So the algorithm defines 3 states that a node can be in at any time. These are the follower, candidate, or leader states, and I use these colors to represent them. And we can see a small demonstration of how it works. There's 3 nodes. You can see a number 0 associated with all of them. If you were present at Cinzia's talk yesterday, you might remember the notion of logical time steps. These are pretty much the same thing. So every node starts at time 0. They all start with non-deterministic timeouts, and if they don't receive anything within a certain amount of randomized time, then they will time out and do something interesting. So we saw the first node timed out first, and so it decided, hey, no one is doing anything, I'm going to try become a leader. So what it does, it promotes the candidate, it increases its time value, so it's at time 1. And what it does is it's going to send request votes to everyone else in the cluster. These followers, since they were still waiting for a message, they received these votes and were like, yeah, sure, this sounds good. So they increased their time values to 1, and they're going to respond to the candidate positively. So they will send acknowledgements back to the candidate, and once it receives a majority of votes, it's promoted to leader. And it's happy and is going to be the governing body of the cluster from here. So, this is the leader election protocol in a nutshell. Can we put a type on it? Well, that simple demonstration, right, has already quite a big type to it. But I can walk you through a little bit of it. So remember, we had these 3 different states, follower, candidate, leader. We can denote these, we can mimic this kind of state using recursive variables. So on the left, you'll see a μf. This is the follower side of the protocol. It begins, and it will wait for a message from any of the other two nodes, I and J. And at the top, I have, if it receives a request for a vote from I, then it can reply with either yes or no. No matter what it does, it just recurses back to F. It doesn't do anything. And it does the same thing for other messages. Right? But in the candidate state, right, to become a candidate, it had to not receive a message for an amount of time, assume no one is active, and say, okay, I'm going to take the lead on this. And this can be seen using the timeout. So if I start up and I don't receive anything in an amount of time, I will time out. And there's the new recursive binder μc. This represents the candidate state. And it sends request for vote messages to everyone else in the cluster. And it waits for replies. If it receives yes votes, then it will promote the leader. And this promote the leader I denoted with a hole in the session type, so that can be filled in later. I didn't bother filling out the whole thing because there's already problems here, as I will show you. But yes, so the candidate, it waits for these replies. Again, if it doesn't receive any replies because failures happen, whatever, it will go back to C and send requests for votes again. And this more or less conforms to the protocol description, but I am not satisfied. Right? There are imprecisions in this. The reason why I want the session type is so that it makes sure I write a protocol as accurately as possible. But there are many things that this session type, although it might type check my protocol, there are many things it does not force me to do. And I don't like the imprecision. And so what I would like is something more like this. Remember those term numbers that we saw, 0 and 1? When I promoted the candidate, I increased my term value. Well, these are integral to making decisions, and they're integral to changing the protocol continuation type. So what I would like is a session type that can do something like this. Right? So if a candidate were to receive a yes vote from one of the followers, it should not assume that that yes vote is valid. Why? Because if I receive the yes vote for the previous election, then I should not promote the candidate. And that could not be described if we don't reason about term numbers. Not only do we get to describe things like that, well, also, if we look at the follower side, the very top line, earlier in the previous slide, I just had a branch type, sorry, a selection type. It said either I reply with yes or a no. Now, with something like this, we could be more precise, right? We say, oh, well, only reply with a yes if the term number of your vote is greater than the one you have. Otherwise, well, why would I vote for you, right? And I can make sure the programmer conforms to these things because they're integral to the correctness of the algorithm. Right, so these are cool. They look nice, but what actually can they be? Right? So these are proposed syntax, and these are possible ways of finding meaning to them, right? What can they really be? Well, can we reason about them through dependent typing? Well, maybe, right? So dependent types would allow us to request more information about what we are, about these term numbers and about terms. But dependent types also are very heavy. They come with their own problems. So maybe it's too much. Maybe we don't need to go that far. Well, we could also think about them through refinements, right? Refinement typing. And there is some work on refinement typing in MPSTs. And maybe this is enough. We would really have to sit it through, try it out, and write the protocol again. Refinement typing will allow you to make Boolean conditions or conditions on the payloads that you're passing. So you can change your protocol based on conditions of these term numbers, which would be nice. Or else, another idea I had is taking inspiration from epistemic logic. And if we had some kind of epistemic modalities which we could introduce into the session types, then we could maybe reason about beliefs and belief systems inside this type. Why is this helpful? Well, whenever I receive a message from someone with some particular term number, then I can hold the belief that they have this term number. And I can maybe change my protocol based on my belief system. And I say I have the belief because, remember, this is a system prone to failure. And if I receive a message with term number 5, that does not mean that you currently have term number 5. It's you had it when you sent that message, but things could have changed. So these are just some ideas I have. I am very interested to see what kind of ideas the community might have. And if you have any points of discussion, please let me know. Otherwise, I am done with my talk. I thank you very much for listening. Thank you.
So since this is runtime checking, I'm not sure we're going to follow that protocol, right?
Yeah, so as I mentioned to you, I implemented Raft also in a session type system, the one that Stephanie and I designed on with shared session types. And there was really no problem doing the implementation. So the way we model communication is there's a single shared process. It represents a network. And the way we get non-blocking communication, that the process asks, do you have a message for me? And the network will say no, or it will say possibly yes. That's why in my talk I had this type store, which is kind of a universal type for communication once you have shared channels. So we got non-blocking input in that way, so we could represent certain things. And we could also represent failure by simply this central process representing the network dropping messages, which is entitled to do, or replicating messages, sending it twice. So the protocol had to be resistant to those kind of attacks. And then you can play with the parameters, and you can see the usual graphs that Ongaro, for example, saw when he implemented his session types. So, so first of all, the good news is that with this very simple change of having shared session types, we were able to get a representation of the Raft protocol. But the same thing that you found, we found as well, which is that the types make sure that messages are understood, but they don't talk about what the messages actually mean, okay? So it can be well typed, and you know when you get a message, oh, it's the correct form, and things like that, which is, I think, already an important guarantee when you compare it to other implementations. And for example, there's no problem to compile this on the back end. Our compiler from concurrency now produces either C with P threads, or it produces a Go using Go routines. So you can run it in either of these configurations. And there's really no problem doing that. But this is still very far from having correctness proof for the protocol. And I think trying to say that the session type has to contain the correctness proof, I think that's too much to ask, okay? Sort of like even a functional type system, right? until we go to a full Martin-Lev type theory, right? The types guarantee you a lot about the interfaces, about how you call functions and things like that, without guaranteeing you, well, if I call this function log, it will back something. If I take it to the power of 2, I get my, the result that I want. It doesn't guarantee you those kind of properties. So maybe we're asking for too much if you want to get all these properties into the type. Maybe we should be happy that we have communication, soundness, type soundness. And maybe there's a separate research project on how to prove the correctness of these things, but maybe trying to fold it all into one is not a realistic goal.
Okay. So I agree with the fact that, yes, it is very important that we can write session types that give us these, at least this line of guarantees that you mentioned, right? So at least we're not getting any unexpected messages. We can handle our payloads, right? But, so in terms of asking for too much, maybe, but I do think it would be a pity if we don't find out where that line is. So where is the line of asking for too much? And how far can we go? So I am interested in figuring out that if this is too much to ask for, then figuring out reasons why it's too much to ask for and why it can't be done. And seeing the boundary of till where can we take it.
Yeah, well, it's also asking too much of the developer, right? I mean, the reason that the systems people that you work with don't write their protocols in Coq is because it's too much to ask of them, right? You give them.
Yes. But yes, so just on this, if we had some kind of generalized system, right, we don't need our developers to write the protocols in Coq. We don't need them to write the full session type. We, as the protocol designers and people looking to verify these things, we can write these session types. We can write these protocols. And we can work on ways of building a bridge between a generalized type that can be spread around different languages and implemented in different implementations.
Thank you for the talk. So actually, it's a bit of follow-up on what Frank was saying. So I got from your talk that it's important for you to have a hold of the terms, right? Yes, yes. But this is something that people doing the analysis of security protocols have already realized a long time ago. You see, because they use the applied pi calculus, and the kind of concern that you have, like this is really the message that I want. They frame that as an integrity property, and they have a lot of tooling, and they have a lot of, I would say almost 2 decades of experience in this kind of thing. So essentially, they use something very rudimentary, you could say, like the applied pi calculus, in order to model all those things. Of course, they're targeting a certain level of abstraction, right? So that was also part of Frank's comment, right? So you have you give different priority, and you look at different levels of abstraction with different formalisms, right? So I was wondering, my question is specifically, have you looked into how people have used the applied pi calculus to formalize this kind of things or this kind of protocols? Because there, for sure, you need to reason about terms, and you pass around terms, actually.
So I have not looked specifically into applied pi calculus and how they do that in that setting. But yes, I will definitely take a look at this for inspiration. Thank you.
Thanks for your talk. This is maybe just a complementary option as well. So the thing is, we get these types protocols that get quite complicated, and they contain things like even calculations as part of the specification or other decision procedures, and that's why it's getting hard to verify in the implementation. And so some of the approaches that people have used, things like code generation or type generation, if you've got that thing in the type and you want the process to follow that, actually that's also one option in some cases where you can generate some of the components or part of the implementation, and it's correct by construction. It might be a bit crude in some sense, but it may be practical as well.
Yes. So there is some work, especially even in Raft, of correct by construction generation of the Raft consensus algorithm. yes, I personally think it's a crude way of doing it, like you mentioned.
Thanks. Thanks for your talk. It's very interesting. May I ask you for an opinion, because you said, like you did in your master's, look into consensus protocols and how to verify those. Like the term number thing of Raft reminds me of this round-based verification approaches, where like communication closed rounds. I guess you know what I mean by that?
Communication taking part in closed rounds, you said?
Like communication closed rounds where you can discharge any message that is like older than something because you progressed further.
Oh, yes, yes.
Yeah,
yes.
so there are these like two approaches that come to mind. One is like p-sync with a follow-up on resync with Byzantine folds, and the other is like pretend synchrony. Do you remember them? And like, because I wonder like what you mean by that you found them unsatisfactory.
Oh, okay, so let me explain myself a bit more there. So what I found unsatisfactory is the approach that I was taking back then. So my approach back then was developing runtime monitors for consensus protocols. And what I did is I developed a runtime monitor and attached it to my implementation of Raft. And the guarantees that you could get out of runtime verification were also limited to some extent. And what I wanted to do was try a different approach, and an approach that seemed more effective into the development lifecycle. And I thought that type systems and behavioral types fit that perfectly, and so that's what I meant by unsatisfactory.
So it's time to move to the next talk. Thank you, Martin. While Ilaria prepares, if your question, Stephanie, is very, very quick. Okay. But let me just make a very quick comment. So even if you are happy with your specification, how do you make other people happy? In the sense that you actually convince people this type is satisfying a few of the properties that you are expected to satisfy in a consensus protocol. So I don't think just specifying the type is enough. You actually need to have some tooling to show what are the properties that it enjoys.
Yes.
And why is it a bad specification, for instance?
Yes, of course. And I think, so those guarantees I mentioned in the beginning, those are definitely the starting place to be, right? So if we can show that our type system at least preserves one of these consensus invariants that we require out of our protocols, that's already better than what we have now, right? So thank you for that.
So Ilaria is giving the final talk of the technical program of ST13. We heard about event structures during the workshop. Now we're having a talk about them. Thank you.
Might be a bit different from... Would you mind if I put this a little bit? I don't know. Might be. Well, actually, my screen is not going there. I should have tried it before.
We just ran into this yesterday.
No, I have to go in preference.
Right. And then displays, yeah.
have display?
Maybe display settings.
Whole option.
Oh, okay.
I should have tried before. Strange thing.
I think this. Try display settings.
Yeah, that's what I did, and then I leave it. Wait,
So
as soon as
you can see my cat when he was younger.
You want to see also the slides here? But that's really strange.
So, yeah, how
I should
does
just leave it. I don't understand why it's not. Maybe I just try to.
So usually there's an option that you can set to mirror. Do you want to mirror it? But it's
doesn't seem to work.
The thing that you are trying to do, I'm not familiar with that. Display settings, yeah, I would try that one. And then right, exactly. That should work.
Okay. So sorry. So this is ongoing work with Paola Giannini, and it's actually the follow-up of, it's a small follow-up on some joint work with Mariangela De Zani and Paola Giannini on using event structures as a semantic model for multi-party session types. And what we did in that work, so I will use MPST and ES as abbreviations in the rest of the talk. So what we did there was to pick a very simple multi-party session calculus where sessions are described as networks of sequential processes specified by sequential global types. And we give an event structure interpretation for both sessions and global types using two kinds of event structures called flow event structures and prime event structures. Don't worry if you don't know about them, I will introduce them. And our main result is that when a session is typable by a given type, then their associated event structures have isomorphic domains of configurations. They have isomorphic computations. Configuration is the name which is used for event structures to name computations. Can you hear me if I go this way? Because the okay, okay, sorry. Okay. I find it more comfortable to move around. And so we did this both for synchronous communication and for asynchronous communication. And the synchronous case is now published at the beginning of this year, while the asynchronous case is under submission, but you can find on arXiv a recent version, just submitted, a revised version submitted a couple of days ago. So this is just for a recap of what we did, and I will have, unfortunately, I know that some of you have been exposed already to this material, in particular some Oxford people there, and Simon, and maybe Peter as well. Actually, here I'm going to concentrate on the synchronous case, and I remember in DAX2 I presented the asynchronous one, so there will be some difference. So here we will concentrate on the synchronous case because that was chronologically the first we studied, and also because the paper was already published, so we thought it was better to rely on that. So, and what this talk will add with respect to the previous material, which I will recap, is some reflections on what this semantics is good for. So, this was not only a natural question to ask in the very beginning, but it was also spurred by several remarks we had when we presented this work. I can remember Simon, for instance, or Nobuko, or some Ray as well. So they all sort of prompted us to explain why we were interested in such a semantics in the first place and what benefits we think we can draw from it. So indeed, we claim this is a denotational semantics for session calculi. So we expect it to provide some abstraction, for instance, and some new insights. And also, since we give semantics both to networks and to global types, can we establish a semantic counterpart for the syntactic well-formedness conditions on global types? And as regards the semantics for networks, can we identify some structural properties that are satisfied by the denoting event structures? And also, since event structure semantics has been, since a long time, studied for various kind of process calculi, how does our semantic compare with these existing ones? And finally, could we go as far after identifying these structural properties, could we go as far as completely characterizing the class of event structures that we obtain by interpreting networks and their global types? So these were the questions we were faced with. And as I said, here I will focus on the synchronous case, and I will just present you some very preliminary results and some conjectures. So, but first of all, I have to sort of set the background. So I'll start with a quick tour on event structures, and please, Antonio, control me because I always overflow. And this is, I mean, there is a lot of material here. I will try to be fast on the first part. So event structures are a canonical model for concurrency, which was introduced more than 40 years ago by Nielsen, Plotkin, and Winskell, and it was the subject of Glenn Winskell's thesis. And what is very appealing about this model is that it has a strong connection with both a particular class of Petri nets called occurrence nets and with a particular class of domains. Remember, those were the times where people were still looking for a denotational semantics for concurrency. So being close to Scott information domain was somehow a good starting point. So the simplest kind of event structures, the ones which were introduced in that seminal paper, are called prime event structures. They are essentially a set of events with two relations of them, a causality relation, which we represent by this arrow here, which is a partial order, and a conflict relation, and which is meant to say when an event must precede another one in any computation, and the conflict relation, which we represent by this squiggly line here, which is meant to say when two events are mutually exclusive. They can never happen together in any computation. And this conflict relation is assumed to be irreflexive, symmetric, and to satisfy this conflict heredity property, which says that if an event is in conflict with another one, and this E prime here causes an event E second, then E is also in conflict with E second. namely conflict is inherited by successors. And this property 3 here, the conjunction of irreflexivity and hereditariness of conflict is quite powerful. It implies that the two relations of conflict and causality are disjoint, and that an event cannot have two conflicting causes. So that's quite easy to see, because if this E2 here were this E, so if E and E prime were in both relations, then by conflict heredity, this E should be in conflict with itself, which is not possible since conflict is irreflexive. And similarly, if E and E prime were both causes of, did I step on this? So we're not supposed to keep a slide for a long time. Okay, I will go faster now. So similarly, if this E, suppose E and E prime are both causes of E2, two conflicting causes, then this E will be both in the conflict and in the causality relation with E2, and we just said that they cannot be overlapping. So prime event structures are very simple, but they forbid conflicting causes, and they partition the relations on events. So the problem with prime event structures is that they are not flexible enough to give semantics to process calculi, and this is a very simple example in CCS. So if you have A prefixing C in parallel with C bar prefixing B, the way you would naturally interpret these with prime event structures would be, with event structures in general, would be to just create a new event, tau representing the communication, putting this event in conflict with both its components happening independently, and then this new event will just inherit the causality relation from its components. So you would like to end up with something like this, but as you can see immediately, we step outside the class of prime event structures here, because here we have two conflicting causes for the same event, and also these two events A and B shouldn't be considered to be in a global causality relation, because there is a configuration when when C bar happens here followed by B, and A happens at the other side, so there is no communication. So in this configuration where we have A, C bar, and B, A and B are independent. So there is no more a global causality relation. So the way people define a prime event structures semantic for CCS is to duplicate actually that event B, so that you keep the properties of prime event structures, but as you see, this has a cost, because as soon as you have a communication, you have to duplicate everything that follows. It's not a natural semantics. So that's why Glyn Winskell himself immediately stepped to a more general class of event structures called stable event structures, which allow for conflicting causes, but which use a second order causality relation on events, which is called enabling. So which defines when a given set of events enables a specific event. So we lose this nice graphical representation we had here. That's why with Gérard Boutol, we introduced an alternative class of event structures, which is just a very slight generalization of prime event structures, so which is comprised between prime and stable event structures, and which remains, still preserves a first-order causality relation on events, and therefore a graphical representation. So now, so we saw that this would be the semantics we would like to get, and in order to do that, we have to relax the conflict heredity property and replace the causality relation by an immediate causality relation, which is not transitive. So that's the very idea of flow event structure. So now the set of events has, again, a conflict relation, which is only required to be symmetric. It's not required to be irreflexive anymore, not required to be hereditary either. And the causality relation is now given by this flow relation, which is just immediate causality. So it's just irreflexive. It's not required to be transitive. And the new feature is that the conflict relation is not irreflexive, so we can have self-conflicts. And these we use to interpret CCS restriction. And now the parallel product on these flow event structures is just a natural one, as I was suggesting before, and it is a categorical product. At least it is a categorical product given a certain structural property which is satisfied by CCS interpretation. And now, so these event structures are already unfoldings. The events actually represent event occurrences. So if you have an infinite behavior, that will be represented by an infinite event structures. But they still have conflicts, so they are not executions yet. And the way, so there is an additional semantics defined on event structures, which is given by configurations, which are indeed a set of events that may have occurred at some stage of execution. So for prime event structures, configurations are very easy to define. They are a finite set of events which is downward closed. So if an event is in the configuration, then all its causes must be in the configuration, and which is conflict-free. All conflicts have been resolved. For flow event structures, the definition is slightly more involved, but not too much. So left downward closure is now required up to conflicts. Namely, if there is a cause of an event, if an event is in the set and there is a cause of the event which is not in the set, that's because there is already another cause of that event which is in the set and which is in conflict. And again, the set must be conflict-free, and also the transitive closure of the flow relation within the configuration must be cycle-free. There shouldn't be causality cycles in a configuration. So within configurations, we retrieve a partial order of causality. Okay, so, but we started a bit later. Let me grab something. And okay, then the domain of configuration of event structure is the partially ordered sets of its configuration ordered by inclusion. And these domains have a particular structure. They are the so-called prime algebraic coherent domains, and this is a result given in the original paper by Nilsson, Plotkin, and Winskell, that the prime element of this domain are in a one-to-one correspondence with the events of the event structure, if it's a prime event structure. So the prime elements of an information domain are those which add a piece of information to the domain, which cannot be expressed as the soup of two other elements. And this is a picture from the original paper, which sort of summarizes this. This is an occurrence net. This is an event structure, pictured upside down. And this is its domain of configuration. And the prime elements here are this one corresponding to E1, this one corresponding to E2, this one corresponding to E3, and this one corresponding to E4. So just because this is used afterwards. So our multi-party session calculus now is extremely simple. Processes are just internal choices of outputs or external choices of inputs. Everything is directed. This is the very basic first restrictive syntax for processes. And again, so this definition is co-inductive, and we assume regular co-induction. And processes may be viewed as trees whose internal nodes are decorated by actions, by p-bang or p-query, edges by labels, and leaves by 0. I say this because our events will be actually paths on these trees, and sessions are a parallel composition of located processes enclosed within a participant. And okay, the LTS is just the expected one. There is nothing, absolutely nothing new here. We write a communication like this. This is P that sends to Q the label lambda. And as you can notice, processes here are just like local types. They send pure labels. They don't, there is no value attached to labels. Okay, so our types should exclude classical deadlock where the participants have mismatching expectations. They should also exclude deadlock due to circular dependencies where the mutual expectations are matching, but there is a causality cycle. And we also want to exclude starvation, namely this kind of what we call a denying choice, where two participants, P and Q here, infinitely choose the second branch, and therefore this third participant here will never get a chance to do its communication with Q. So we want to exclude this as well. So our global types have the standard semantic of global types, where choice is between a fixed pair of participants. And again, this is co-inductive and so on. The LTS is also the expected one, so you can do a communication at the top level, but you can also do a communication under a choice if the communication is independent from the choice. Projection is just like the original projection, except that it's defined co-inductively, and therefore, so it requires for a choice every third participant to have the same behavior in all branches. But since it's defined co-inductively, it actually admits more sessions than the inductive definition. For instance, this type here is projectable, while it's not projectable with new definitions. So this type here means that P sends to Q either the label lambda 1, and then Q sends to R lambda, or P sends to Q lambda 2, and then it recurs. So in fact, this type is projectable in our setting, but it will be excluded anyway because it's not bounded. And this boundedness is the second property which we require for well-formedness, because in order to prevent starvation. So well-formedness will be the sum of these two properties where, okay, I forgot to say what boundedness means. It means that, global type G is bounded if for each subtree G prime of G, the depth of the first occurrence of every participant is bounded over all the paths of these G primes. And this property is not satisfied by that type. The type system is also very much standard. Okay, I will not. And the properties it ensures are subject reduction, session fidelity, in quite a strong form. So this implies that the two LTSs are of a type, and the type network are bisimilar. And also this property of progress, that if there is a component a participant whose process is not terminated, then eventually that participant will be able to do a move. Okay, so that was okay, so well, Yeah, so the event structure semantics takes some time to explain. So I will just say that, let me just go quickly. Okay, just say that an event in the event structure of the network will be a pair of what we call located process events. So these are events of two processes P and Q run by participants P and Q. And as I said, here actually the event of a process is a path in its syntactic tree. So this pi here is actually the action whose occurrences we are specifying, and this z, which preceded, it's the sequence of actions which must which the process must do before doing pi. And so our events will be, by construction, they will have to be dual, not only in their last actions, but also in the histories, in their sort of causal histories to reach these actions. So these are the events of a network event structure. And okay, I will spare you everything. I just want to show you that there is some confluence after conflict in these event structures, because, as I said, conflict is not hereditary anymore. And just by interpreting events syntactically, as I said, we reach situations where there is, the same event can have two conflicting histories, can have two conflicting sets of causes. You see, this is the communication between R and S at the end of the execution of this process here. So first P and Q have to choose one of the branches, and then P communicates with R, and then Q communicates with S, and finally R and S can communicate together. But by the time we arrive here, since here we retain only the local history in R, we have forgotten the initial choice between P and Q. So that's why we have this confluence. And instead, a global, so an event in the event structure of of a global type is something different. It's based on traces. So it's, again, we take the syntactic tree of the global type. We take a path, and a path leading to a specific occurrence of a communication. And then we build the event from there by taking off from everything. So we take a path of this kind, which represents a specific occurrence of alpha, and then we take off from this path in the tree all the communications which are not causes of the last communication. So in the end, we get something of this kind. So actually, we start off with a sigma prime, which is a path in the global type tree. And after taking off all the unnecessary events, all the unnecessary communication, we end up with something like this, which is an equivalent class because it's taken up a permutation of independent communications. Okay, so that's just to give you a flavor. And so this is a type that types the network for which I show you the flow event structure before. And now the event structure we obtain is different because it duplicates the final event. Why is that? Because it keeps the whole global history here. So you keep all the causes which transitively, all the communication which transitively cause the last one, including those which do not involve the participants of the final communication. So that's just to give you a flavor because, okay, and in the end, we proved that the configuration domains we obtained in both cases are isomorphic by just lifting the configurations to the level of networks and global types and exploiting our results of session fidelity and subject reduction. Anyhow, so this was what we did before, and now the question was, so what have you achieved? Why have you done that? I mean, all this work for. And we claim that we have gone a little bit further on replying to these three questions. So for this one, we can say something precise, and for these two here, we are halfway through. So this is about the abstraction, while we have to speak louder. So when we construct our events for networks, actually we get rid, I didn't show you all that, but we already, so the classical deadlock example I gave you in the beginning, where you have mismatching expectations from two participants, this one gives rise to the empty event structure, just because you cannot build such an event with dual histories and dual actions. And this one I didn't show you, so anyway, we also rule out events which are not causally well-founded. So we already do some sort of garbage elimination when we define the semantics, while the three-philosopher deadlock, the one due to a causality cycle, this one gives rise to three events, because these events are mutually dual, but and they are all well-founded, but the only configuration is empty. So there is no configuration where they can occur. So here we get more or less the same thing that we get with an LTS. There is no additional abstraction. And so maybe this question, so we partly abstract away from deadlock. So we just throw away these deadlock states. And is this good or not? Can it be viewed as a sanitization? Now, when it comes to the semantics for global types, so as expected, we turn the implicit concurrency into an explicit one, because concurrency is primitive in event structures. And our main result is that global types that type the same network give rise to identical event structures, prime event structures. And so this is a bit stronger than we expected. So we could expect that they would give rise to isomorphic event structures, but we get actually a stronger result. And that's because of the way, of the syntactic way we build events. And so I'll conclude with this. So we have some semantic counterparts for the well-formedness conditions on global types. Now I'm not going to bother you with the technical definition, just to tell you there is one. We haven't completely proved them, but we are halfway through. And so also we have a semantic counterpart for boundedness. And the conclusion is that, okay, we have given this event structure semantics for synchronous sessions types. For typeable sessions, we have the equivalence of the two semantics. So this was our previous work with Mariangela. And here with Paula, we have some preliminary results on the benefits of our semantics. So this is the most related work. And I think there is also, since I see Franco here, I think there is also work by you and Ugo and you don't, maybe I'm wrong. So maybe it's this work, which is, but in both cases, it's for asynchronous communication. Okay, and then I leave you that.
questions? Marco, please.
Just a quick question. Sorry, I missed
To
the
be
first
recorded,
part.
do you mind just waiting?
Oh, sure. I think I missed the first part. I'm sorry, I was in another talk. But so you mentioned this global types that they have the same event structure. Syntactically, what do they differ on? Maybe I missed this bit.
No, they have syntactically the same events. So if you have two well-formed global types that type the same network, they give rise to exactly the same event structure.
Yeah, but if I had to look at an example, what would be the difference between two equivalent global types? Are you, for instance, swapping interactions that are on different roles, or?
Yes. You swap interactions. So maybe, I don't know if you were here, you start with a path so you may have different global types where an action occurs in very different places. So you start with a path in one of them, then you prune all the communications which are not causes of the last one, and then you take it up to permutation equivalence. And since all that is specified syntactically, you end up with exactly the same syntactic expression for events.
Okay, I also have a question on your slide about the deadlock. You were saying that, so you have empty configurations, but the
you mean the last slide?
Yeah. The last slides.
Okay.
But
anyhow, it was this one. For this one,
can you reason on the other direction? So if you having empty configurations, is that bad, or there are multi-party processes that make sense and have empty configuration there, right? So you cannot use the approach as an algorithm to decide for deadlocks, right? So what do you provide actually?
By way of
detecting
a detecting algorithm. So if yes, maybe we would need some additional information on the event structure to mark the states which somehow have no successors or ending states without being terminated states. Because at the moment we do the construction, we know this. So we could want to remember this. Look, this is a kind of bad sync event or something. We could, yeah, indeed, this is a bit brutal. You just take them away and forget about them. But a good thing would be that somehow once you have this event structure without the deadlocks, from that you can reconstruct a network which is sanitized somehow, which doesn't expose this.
So thank you all. Thank you, Ilaria, again for the talk. So we reconvene after the pause at 4:05.
Well, I was going to suggest 10 past.
10 past. Okay, very generous.
Volevo chiedere, questa domanda va bene. No, forse l'hai detto, però avevamo il nostro talk. Un esempio di due global types che sono diversi.
Right, okay, so let's get started. So welcome back. This is the final session of ST30, and this is going to be our panel discussion session. The session is being streamed, which is why we've got this slightly unexpected layout of the seats. We didn't manage to move the camera, so this way we've got a reasonable view from the camera and also from the room. And so also because of the streaming, we're going to have to use the microphone, and we've only got one microphone, so we'll have to follow the protocol that you speak if and only if you're holding the microphone. So this should also have a calming effect on the discussion. So we've got three panel members, Stephanie Balzer, Ornella Darther, and Raymond Hu. We had originally got Luis Caires as a fourth panel member. Luis, unfortunately, is ill with COVID, so has had to miss the workshop, which is very sad. He emailed yesterday to say he'd watched some of the sessions on the stream, and he was missing us all. And if you're watching this one, Luis, we've missed you as well. It's such a pity that you can't be here. So what we're going to do is, first of all, I'll ask each panelist to briefly introduce themselves, say who they are, where they're from, maybe what their main work has been. And then the topic for the discussion is future directions for session types. So I'll then invite each panel member to make a brief statement about what they see as future directions for session types. And then we'll open up to questions from the audience. So for each question, all three panelists will have an opportunity to give an answer in some order, not the same order every time. And after the panelists have given their views, we'll open up for further comments or discussion from the audience. And we'll see how we get on. And we've already seen some quite lively discussion after some of the talks in the workshop, so maybe some of those topics will come back in this session, or of course new topics. And I've got a list as well in case the questions are not coming at a fast rate. So let's start with the introductions. So we'll pass the microphone along for each panelist to introduce themselves, starting with Stephanie.
Okay, hi, I'm Stephanie Balzer. I'm an assistant research professor at Carnegie Mellon University, USA. So I'm interested in one line, verifying concurrent systems. And I'm using session types actually a lot. And I've been employing session types for a few years now. And I think there's so many applications out there that are really very well suited for session types. So I think I will be working on it for much longer.
Hi everyone, I am Ornella Dartha and I am a senior lecturer or associate professor at University of Glasgow, and I've been in Glasgow for almost 10 years now, so as a postdoc and previously as a lecturer, and I work on session types. My main work that maybe the majority might know me for is the encoding of session types in linear types. And I'm interested in general in expressivity of session types. More recently, I've been working on session types and failures, and I'm interested in understanding the more salient features of large-scale distributed systems and how session types can be used to address those features.
Hi everyone, I'm Raymond Hu. I'm a lecturer at Queen Mary University of London. If you don't recognize me, this might help. So you probably see Nobuko's slide with the back of my head in her. This is the slide that she often shows. So this is me. Yes, I'm at Queen Mary University of London. Until quite recently, my office was next door to Kohei's old office, and it was very nostalgic for me because so I've been working in session types since I was Nobuko's student working with Kohei as well. At the beginning, we were interested in implementations and applications of session types as language extensions, and then later on we were interested in session types without language extensions. Some topics I've been working on recently include session types with refinements, failure handling, and for rate-sensitive systems, which my co-author Grant there would speak more about on Friday if you're still around.
Okay, thank you all three. So let's go in the same order with the opening statements about future directions in session types. So Stephanie first.
Okay, so I think I agree with both Ornella and Raymond that handling failure, so failure handling, I think is a really important topic. And I think it's connected to distribution. So we have many applications today, like cloud computing and so on, that are inherently message passing, but I think many of those are also distributed. And I think with regard to distribution, even though session typing seems to be very well fit for it, I think we haven't really addressed that aspect fully yet. So I think that's important work that has to be done in combination with failure handling. And another thing, maybe someone else will tell me that I'm unaware of some work, but I think module systems for session types is also something that is missing.
So I think I will, this will sound a bit like a project proposal now, but the way I see future direction for session types is in three main areas that are in no particular order here: theory, implementation, and mechanization. In theory, I think after 30 years of session types, we are now in the position, and recent works have shown this already, that we're ready to integrate relevant salient features like failures or congestion or timeouts and anything of the sort to make the theory closer to reality. The second one, implementation. So if we want session types to be used by programmers in their everyday programming work, then they need to be properly integrated, same amount as data types are in mainstream programming languages. And mechanization, so we don't want to paper after paper when we build on previous work to correct bugs of 10 years ago. So mechanization is really important so that the theory is nice and stable. And not only because of that, but once upon a time, the key examples of session types were, well, buying a book, the bookstore, or that for multi-party, or the client-server, the addition example, which are nice examples, but I think we've moved now to more relevant examples like authentication, or I've been looking into embedded systems and self-driving cars. And if in the future we want session types to really be integrated in this system or verify this system, then they better be correct. Because I mean, we don't want our self-driving cars to actually crash because of the verification, which is far worse than, you know, crashing for when buying a book. So that's those are my three main directions.
Okay, so yeah, one of the topics I'm interested in is, as we all are, is implementations and applications of session types in practice. And we know session types are challenging because they deal with all of behavior, ownership, and invariance, all the key topics of PL or something. And a good account of session types has us have some account of all of those things in one framework. And so, yeah, we have to deal with session types are fundamentally behavioral. It's about evolving behaviors in a concurrent non-deterministic model of computation. And we want to do this in a PL framework, for which purpose we usually have to have some infrastructure for resource, like fine-grained resource control, like linearity or alias control. And then all of this is put together with some kind of compositional invariants like duality or consistency or compatibility or whatever it is that you happen to be using in your system. And that's even before I even mention things like asynchrony and failure handling and all these things. So I think we should give ourselves a pat on the back for being so good at working on all these challenging problems. So whilst I was trying to think of what my vision would be for the future, I was thinking about this, and I realized there's been a lot of very nice works over these years, and I surely myself don't understand all of them perfectly. And I think that's one thing I realized is that maybe myself and as a community, we should try to maybe take stock of where we are and try to understand what we've learned actually in all these different works that we've all been doing, separately, so to speak. What we've learned from that, and how we can use what we've learned to put together this vision of what we might call a success goal for the community in terms of implementation and applications. I mean, we've had so many different approaches, right? Of course, you have implementations of languages from first principles, so it's got an account of all those features that I've mentioned. That's surely session types. But I don't know, maybe that's been the less common approach, actually, especially in the last few years. We have a lot of encoding approaches, encodings into mainstream languages, for whatever that means. And because mainstream languages don't have an account for nearly all of those features that we mentioned, we have to get creative, and we have to do things, find ways to live without maybe all those things. For example, one of the techniques I've used, and I think others have used as well, is looking at session programming in a event-driven context. So event-driven programming, of course, is a major paradigm in practice as well. And it turns out it's very nice because not only is it practical, but you get to do away with channels completely. You just react to events. It's a bit similar to the talk we heard this morning as well. And so that's actually one of the major difficulties of session types in practice, instantly bypass. But if there are no channels, is it session types? That's what I also started to think. I wanted to understand what are all these implementations of session types, and I started to think, well, what is an implementation of session types, and what even is session types in practice? And I think that's something that we can, there's no single right answer, obviously, but something that we can discuss, and that will also inform the kind of directions that we will go to. I'm sorry, am I taking too long? Yeah, I mean, as well as encodings, once you start getting creative, you think, okay, if I take out this part and I can live without that part, if we push it to the extreme, is it only the properties that we care about? Is any language, sort of program language style approach that gives you some kind of communication safety or progress, is that session types, And maybe they are implicitly thinking about static properties. But of course, there's been plenty of work on dynamic session types. I'm happy to call it runtime session types, but is it session types actually in that sense? So I think these are all really interesting questions to talk about. And so if we can learn what we have already done, and then we can think of some things that we want to target, and I'm sure we all think similarly. One thing that I remember when I was a student, going all the way back to when I was a master's student, I was doing at Imperial, and I was taking this very nice PL course from Sophia Drossopoulou, and one of the topics she did was ownership types, and that was very nice. And at the time, I was just a student. I liked learning about it and studying the theory, and she even put it in the exam, and I did quite all right in the exam, so I was happy in the end. Didn't think much about it for a while, but some years later, and then we have things like Rust, right? So again, I'm not a Rust expert, I'm not an ownership types expert, but it's sort of encouraging to see something which at some point was clearly theoretical and research, but it's made it through to the mainstream, so to speak. And maybe we can try to think how, as a community, we could try to approach something like that for session types or behavioral types or one of these things. But for me, it comes back to one of the key challenges is really this linearity thing, right? There's a point where it seems like session types and these things, they're just applications of linear types. And so there seems to be quite a division between, we have lots of theory built on linear type, linear frameworks, but not so many implementations of that. Whereas actually we've had quite a lot of implementations that try to bypass linearity, but maybe not so much theory, let's say, supporting session types and settings without linearity. We've heard some talks in this week maybe going towards that direction. So I think maybe these are some of the directions that we could talk about, and I'm sure people have some good ideas about this.
Right, thank you all three. So let's see who's got a first question from the audience. Hopefully our assistant will help with the microphone. Okay, Cinzia, thank you.
So thank you for your inputs. And this is a kind of provocative question. So you have replied to the question, what could be the future of session types? But do session types have a future? The problem that I see is that I'm taking a look at ETAPS, Confess, and I see less and less of papers talking about session types within the historical form of a process algebra. So how can we make survive our community, since it seems sort of dying, and having seen the future direction, it shouldn't be die. So do you have any ideas? And it shouldn't be die, in my opinion. And sometimes conferences are just a question of style, fashion, and modern topics. So, but did you analyze the current trends of submissions, and can you see why this is happening and a way out, maybe?
No, that's a very good question, and I have been thinking about it myself, but from another angle. For example, years ago, Concur was the targeted conference for session types, and in general, PyCalculus. And recently, in the recent years, well, there are fewer and fewer papers on session types. But I think that's mainly because they have been promoted to another, they have ascended to another level. So now you find more papers in POPL, UPSLA, ESOP than you used to before. So I think it is mainly a shift rather than a decrease. But now, said that, I don't have the numbers of papers, like how many papers we had 10 years ago on session types and now. So if there is that graph that shows that papers have decreased, then maybe we can discuss it differently. But I haven't had that impression that the number of papers is decreasing, but rather that the venues have shifted and they are going more into PL venues as opposed to theory venues, because the community is also shifting from PyCalculus more to languages. Yeah.
Thank you. So yeah, interesting question. Do you have the stats for session types is dying? Okay. Okay. But I think I agree with Ornella, and I think we've seen several talks this weekend. Frank also explicitly mentioned in his talk. Besides PyCalculus, there's quite a lot of session type frameworks set in, more, let's say, practical languages, functional languages. There's been work in object-oriented languages, and trying to use techniques that. Sorry to mention it again, but I think the linearity thing is something that is very important, right? And so maybe that gives us two broad directions. One is we have things like Rust, which is a mainstream language with some powerful account of resource control. And so maybe we could start to, and we know that once you have that, you can have things like session types and type states and things like that. They're much more accessible in that framework, right? So one option might be to think of languages adding that kind of facility to other languages as well. And the other is, as I mentioned, trying to look at practical language settings that can try to find some way to address that linearity issue for channels or whatever it is that you're reasoning about in some practical way.
I think it's an interesting question. I tend to agree with you. However, I'm not sure whether the numbers are declining, but also the community, the session type community is quite representative. And maybe from that perspective, maybe we're not so well represented at those PL conferences like POPL, ICFP, ESOP, and so on. But I don't know. I mean, my view would only be subjective as well, and also submitting myself and serving on PCs. However, what I notice is that, and I think maybe that's the problem, that there seems to be like a divide between like people who are very familiar with like natural deduction lambda calculus and people who are familiar with process calculi, sequence calculi, session types. And only a few people can do both. And I think like at conferences like POPL, ESOP, and so on, so more PL conferences, I see that more people fall into the former. So they know really natural deduction, lambda calculus. And I infer that from questions that I get when I'm submitting or where I also like co-review papers. And maybe a reason for that is like a programming language class taught at, I'm no longer familiar really with the European system, but like take TAPL, Types and Programming Languages. So it focuses really on lambda calculus. So maybe that is something that could be changed in the educational system so that people get exposure to both paradigms. And I think that would actually help us. Because I really get sometimes feedback where I get criticized for my heavy notation from outsiders, which doesn't really make sense.
Thank you. So any comments from the audience? Maybe anyone who's been on a PC chair recently or something, or might have comments about submissions on session types? I think, Marco, were you raising a...
Another question.
Well, a comment on this.
No.
Right, then for the next question then. Okay. Right, well, let's go to the next question, which seems to be from Marco. Oh, sorry, no. Yes, sorry. Antonio's reminding me that he had put his hand up earlier, and it was so long ago that I forgot. So let's go to Antonio first and put Marco in the queue.
So the question/comment is that on the implementation side, and so ownership types, they came to solve a very urgent problem, memory and safety, right? That was a really pressing problem, and putting the compiler taking care of memory and safety was clearly important, right? Now, what we are providing is less clearly a crisis, right? We don't have the $1 billion mistake problem. So I think we need to show that there is a way of, in an easier way, getting programs correct. And for that, we also need help from software engineering people. Because I don't know how to do an evaluation on what you gain with my approach to use behavioral types in programming languages. So I'm convinced this brings something. I'm convinced this brings better software and you get correctness by construction and by the compiler, but are we actually offering to the world a gain, a concrete gain? For that, we need proper studies from people that know how to do them. Right?
Would anyone in the panel like to comment on that? I agree. So when again, I'm not a Rust programmer, but as I understand, it's dealing with the ownership and resource control, and it's something, I don't know, it's the best word for it, pervasive in a language. It's something that's been controlled in every variable access or assignment, or every argument that gets passed in a call and things that get returned from a call. It's very pervasive. Whereas if we look at distributed systems, something that involves a reasonable amount of communication if you just look at it in terms of something simple like the number of lines of code or something. The amount of code that's actually I/O specific is probably relatively small compared to perhaps the size of the whole project. So it doesn't So if we think of session types as just types for protocols on channels, very specifically like this, that is traditionally formulated, it doesn't have that same kind of pervasiveness. But perhaps that's what we need to do is try to think what we might fundamentally extract from what we've learned from session types and these kinds of approaches in this PL setting. And personally, I think something like type states is something which is a bit more pervasive than just the specific I/O instance of that. But I suppose what type states lack and session types have is the account of composability, I suppose. But I'm sure that people who know type states better than me might be able to point to some works in this area. But yeah, perhaps we can try to think what have we learned from session types in that regard, and how to really build a language around what we've learned from that isn't necessarily just about channels and explicit typing of channels.
Okay, thank you. So I think let's now go to Marco, which I think was a next question. Is that right, or is it a further comment? The next question.
Okay, so my question is a bit of a stretch. One thing that I'm thinking about the hype of the moment, which is statistics, machine learning, these kind of things. And does any of you see any connection from what this community is doing towards that direction?
Well, that's in another department. So we have 7 departments in the school. So I don't know. It's a really good question, but I think it's really a hype. So, and I think it's blown out of proportion. And people who don't know anything talk the most about it. So that's the problem. So what I think what we can do as a PL community is to target verification, because all those, to my knowledge, all the software generated by AI is, I'd rather have a human actually implement a flight controller than an AI agent, or like a neural network. So I think it's probably something that we should look into, and how we can together basically meaningfully contribute to that area, but I haven't thought about it. That's my comment. So it would be an opportunity, I guess.
That's something that I've been trying to somehow to fit together, because I was curious as well. Is there something that can link session types to machine learning or AI? And I don't have an answer yet. But when I've spoken to people who are expert in AI, every time I explain session types, then they say, oh, and then you can use ML for this and yada, yada, yada. A lot of terms that I don't get because they are specialized. So it seems that there might be something, but I haven't figured it out yet. But it is interesting. And I think there are maybe projects that will be proposed soon, hopefully, that will link the two areas. So fingers crossed.
So I'm not a machine learning person, but maybe one area that I may have seen that might be relevant is to do with inference of protocols. So maybe not just inference, like type inference from a language, but also possibly from inference from a set of traces or runtime logs or something like this. So again, I'm sure that people here are much more expert than me. But if you if you have a set of traces sort of inferring the automaton that accepts those traces, it's very easy to be overly naive, right? You can always just construct something very directly, but that might not be morally the protocol that you might want, and there may be some possible applications of using some heuristic techniques, which, I don't know, machine learning might be one possibility to go into this, to try to infer more realistic protocols from these things, for some meaning of realistic.
Thank you. Does anyone in the audience have any comment about machine learning or AI and session types? Nobuko, yeah.
So there are two of areas we can link easily for AI. One is, for example, concurrent robotics, and I once studied with MPI people, and another area is, of course, multi-agent. This is quite easy to, because anyway, we are doing actors. Another thing, I'm not a specialist about it, but several actually people in this room has a European grant, TARDIS, and Novizada people is actually working on federate learning, and they try to use a global type to model it. So if we success this deliverable, we have some real connection with distributed learning. But we will see. Actually, I'm not really specialist, so but that would be. I think it's possible to just looking around. But I don't know Glasgow team is submitting some grant proposal. So I actually want to know more about.
Okay, thank you. So let's, I think one topic that came up in one of the sessions yesterday was about mechanization and the whole area of mechanization. And I think Felix had framed this question in quite an interesting way, and maybe he would like to restate his question, and then we can have a little bit more time than we had yesterday to discuss it. So if that's okay, Felix, we can get you to put your question.
So the actual question I had yesterday was how much more overhead actually use a theory improver session. And the reason why I was asking is I explained a bit yesterday in the a number of bug transition, a call for transition to mechanized proofs, obviously. Quite a lot of effort, obviously, as like an initial framework. Then from the community, it was expected to kind of pick up from there, right? Then I also know, and I think you probably also know separation logic with Iris, the framework that Derek Dreyer has proposed. And then there, this was really picked up a lot. And I've heard about stories where people could not basically publish papers anymore, where there was no mechanization, even though they might have had new insights. Maybe because the foundation was not like matching what Iris provided, but redoing all of the foundation would not have been feasible to actually just one publication. So now I think the question for this panel, which is more interesting, is how do you see a transition towards like all mechanization, like that people, like everybody will mechanize things, and how does this affect the number of publications also compared to like these hype topics like ML and like machine learning and artificial intelligence? And okay, and so sorry, I missed one point for this part of the added overhead. I think, for example, that our calf paper would not have been possible if we were required to mechanize all these proofs. Like this required, I think, probably 200 to 300% of the effort that we already put into it. And I've did masters in like Koch theorem proving everything. So yeah, that's my estimation.
Okay, so how will it happen? Well, I think slowly, and in different amounts. So often what happens now is that the theory comes first and mechanization comes maybe as an afterthought. So sometimes that's, well, almost double the work. And as such, people are discouraged and just happy with pen and paper proofs. Then when it comes to mechanization per se, up to a few years ago, it didn't seem it added much for different reasons. First, I think we are more fed up now with bugs than we were back then, you know, finding bugs in previous papers, and it's yet another subject reduction that maybe doesn't work. So it feels more urgent now than it did. And also didn't seem that you could find appropriate venues to go for. Right now you have CPP, ITP that are on theorem provers, so it is more mainstream than it used to be. If instead the work is in parallel, or you are thinking of your paper in the mindset of, okay, this will be mechanized, then I would expect, as I've done with some of my PhD students, that the time that it takes is of course less. Maybe not same amount as it would take on pen and paper, but you have added value for that added time. So I would expect that in the future, then maybe a paper will be conceived with the proof checking in mind, as opposed to doing it afterwards. And Jules is not here, so he did it as part of his PhD, has 7 publications, all of which are mechanized, so it is possible.
Okay, so I wanted to add to that as well. Actually, Jules is Robert Krebers and my student that we've been jointly co-supervising, and almost all of the 7, but not all, not everyone. I think the probabilistic programming one is not mechanized. I don't know. So I think, so what I kind of see from the work that I've been doing is, so we started mechanizing meta theory of session type languages. So we have, and not only session types, we also have, like this year's POPL, we had a paper on a type system with higher order locks. So a lambda calculus based type system. And so what happens is, so there we've been very successful with publishing. Also I should notice, which is maybe interesting, that the session typed works all are embedded in a lambda calculus. I think that made it more friendly to the POPL audience. So for that work, it took us about a year to build basically we have a connectivity graph library in Koch that allows us to reason about acyclic graphs. And so we took about a year to build that infrastructure and then have the first result. But then we could build on that infrastructure, and actually 2 more papers came out of this. So I think you can do some bootstrapping work and then build on it and still be successful publishing. But then on the other hand, like the meta theory has already been in place, right? We know how to reason about deadlock freedom, memory leak freedom using linear type systems. So we were basically building on all the prior work of people doing, doing this kind of works with using pen and paper proofs. So on the other hand, right now, I've been working on logical relations for session type concurrent systems for the past, I think 4 years now. That's, I think, when I started. And we're now starting mechanizations of all those results. But clearly, we could not have done, you know, we can't use IRIS because IRIS, I think we have a different perspective of things, and it will be actually interesting to explore what that means in terms of mechanization. So I think my I guess summary of what I'm saying here, the conclusion is, I think you have to strategize. So focus on some work that is mechanizable, like maybe with 1 year's effort, and then you can build on it. But then on the other hand, there will be work that takes more. That takes probably 2 years until you can start building on it. But that being said, like there is some work, like the logical relation work that we've been doing so far. Now we are at the point where I don't want to touch the proof anymore, because it's like 60 pages or 70 pages LaTeX. So it's no longer scalable. And if I want to do the next steps, I'd rather have a mechanization.
Thanks. I probably don't have much to add. I suppose I'm on the side of the camp that needs to be persuaded to do more mechanization. I think the talks that we saw yesterday from, for example, Marco and Lorenzo were very helpful in that regard. For somebody like me, it would be very helpful to understand better, to have very simple explanations of what specifically about session types is, you know, the issues related to mechanization, as opposed to just more general PL mechanizations and things like that. And I look forward to when Lorenzo has finished this framework and we can all just use it with minimum effort and it all just works perfectly. And so.
I wanted to add to a comment that you made, Felix, about how did you phrase it? Like, what about like the foundational work that is necessary so that we can all then start mechanizing things in the future? And I think that foundational work is really, really important. And that foundational work has it much harder, that's my subjective impression, to get accepted at conferences. Precisely because you have done those comments, oh, but it's said that your proofs are only pen and paper, rather than being mechanized. But I think it's important to give space to work that kind of bootstrap future work that then can be mechanized. It's feasible to do that mechanization effort. But in the beginning, it's not. I mean, even doing the pen and paper proofs in a very detailed fashion take a lot of time. Yeah.
Thank you. So it seems to me that what Stephanie in particular said is quite consistent with the idea of having a research program rather than just thinking in terms of particular papers. And I think that's a good strategy in any case. If you're, you know, over a longer term. Now, it may be that within the context of a PhD, it might be less easy to have a long-term research program in that sense. So there are some hands going up. I would quite like to hear in a moment from Brigitte on this one, but you can compose yourself while we go to the people who were signaling for comments. So I think I saw Marco and Jorge. So let's go to Jorge first.
Thank you. So I have a question for everybody, actually. So one thing of thinking about the future of our community is, of course, publishing and how we manage to move collectively towards publishing. Another way of thinking about future is funding. So, of course, everybody has a different view of funding. And in the Netherlands, we have this very peculiar situation in which there is no funding, right? And not only that, the idea of formal methods being already embedded so intrinsically in all departments that there is no longer need for a formal methods subunit, for instance, in CWI, right? So, my question is, how do you see the perspective of session types in the future, also in the context of funding? How do you convince other people, like these panels that come from different sciences and different disciplines? How do you pitch the idea of session types in that context? I think this is a much harder and a different kind of problem than publishing and so on.
So let's put that on the stack for a moment. I sort of misinterpreted your signal because I wanted to stay on the mechanization for a moment. Well, we're going to finish at 5:30, if I'm not mistaken. I think all the sessions are 1.5 hours. So Brigitte, are you willing to say something about mechanization in general and perhaps as applied to session types?
So I guess I want to pick up on your comment that what is different, I guess, for session types versus other PL systems, and why has it been fairly successful in the popular community to mechanize parts of the papers, at least. I don't think it's 100% of the papers that have been mechanized. So I think there's always room for papers that are not mechanized, but I do think it's become sort of more common that PhD students also mechanize at least part of their work if it's in the non-session type world, in the functional world. Okay, and part of this is, I think, that there was sort of a learning curve that people have sort of settled on what they think is sort of a successful way of doing it in systems like COC or ACTA, and I think the most common way of doing it is at the moment is well-scoped Brin indices, which is sort of a good middle ground for ensuring that the terms you work with are well-scoped, and but you get certain infrastructure. But it has taken a really long time to get there, right? Like, I mean, if you think back in the 90s, there was a lot of people trying various kinds of dependent type encodings, locally nameless, higher obstacle syntax, and how far we can push these kind of things. And so I think part of it is understanding, what in this design space, in this open world that you have in systems like COC, what is the path you should take? Okay, and so that's partly experience, but it's also partly sort of learning from systems like high order abstract syntax. What are good ways of thinking about these kind of things? And in the session types world, there really is sort of for me, there are sort of two challenges. One is that you have this notion of linearity, which is really we haven't dealt with in the past before. And that has all kinds of implications on where things are bound and how you manage your assumptions. But the other challenge is that it comes from, that it's much easier to mechanize something that comes from a logical foundation. So if you look at Frank and Louis Kairish's work or the classical process calculus from Phil Wadler, then there we see more clearly where things are bound and how the context is managed and so on. And so part of it is maybe that the community, the two sides need to grow a bit more together. Okay, the logical side on the one hand, and things that are inspired by multi-party session types and other formulations of session types, which might not lend themselves directly to mechanizations as elegantly at the moment. And so the bar becomes quite high in order to mechanize them. And therefore also take a lot of time, right? But I think in general, it's part of it is it's a learning experience of how we design these systems and then also building infrastructure. I think what Stephanie has been saying, I think that is maybe reusable also in other settings. But I think it's a really exciting way to think about how we can evolve these systems, because I think it's not only mechanization as a means end, right? It kind of gives us something back, and I think both Ornella and Stephanie have commented on this. So I think it's valuable because it also clarifies our own minds, right?
Thank you very much.
So thank you. I mean, I know we have other enthusiastic mechanizers in the audience. Would anyone else like to comment about their experiences of mechanizing theories of session types? Okay, Lorenzo, thank you.
So yesterday I presented this concurrent mechanization benchmark, and I got your question, right? And today it was repeated. I think that, of course, the panel and Brigitte has answered better than I could. They are more experienced for sure. But I have my small experience in mechanizing either traditional PL concepts and then multi-party session types. What I have seen and why I think projects like ours have value is that the two things, so both the session types, but also the mechanization community and the mechanization support, so proof assistants themselves, need to grow. That's why in one of my last slides, and I'm sorry if it wasn't clear because it's because it was prepared last minute, and I apologize for that, but it was the concept of both community benefiting by them. So the support that proof assistants offer now is somehow still at an early stage. If you don't accept this comment, accept this other one where much more can be done for them. And in my experience, that I have experienced both in Isabel and in Koch, this is definitely true. I mean, this is 30 years of session types, and Ray was pointing out that session types are not well integrated in programming languages yet. Proof assistants are not considered mainstream programming languages yet. They are younger. And yes, so this thing of the need of growing also of proof assistants to get to a better support and more easier mechanizations is there. Therefore, but, and Brigitte said it perfectly, but there's something, if they grow and we start using it, we get something back. And that was my comment, again, in the talk, about the additional knowledge we get from them. So, yeah, so substantially, I agree, and I think that there's a lot of space for good evolution.
Thanks. No, I will not settle this, but okay. Thanks a lot for your comments. As I phrased yesterday the question, it was like on purpose a bit provocative, and I'm actually by no means against mechanization. Like with my background, I see the value. I just wanted to see how you imagine this future towards a transition towards actually everybody mechanizing. And I think that's an important matter to discuss because it's important for the community also in terms of growing and publishing. Thanks.
I think I'm a bit surprised so thank you for Brigitte and Lorenzo, who explained how we can get something back from the mechanization. I'm no expert on mechanization at all, but I think they simply shouldn't be opposed. They are both essential. I mean, mechanization and fundamental theoretical work. And I don't agree at all with you, Ornella, when you say I'm fed up with finding bugs in pen and paper papers. I think if you find more bugs, it's because we take less time to write these pen and paper papers. Because we are pushed, we are sort of drawn into this accelerated rhythm of publication. We try to compete with communities which have nothing to do with us, like machine learning and artificial intelligence or whatnot, vision, computer vision. We just shouldn't compare with them. I mean, we are different communities. We know very well that all these impact factors depend on the size of the community. They depend on the publication practices. They are badly affecting our publication practices. And I think we should keep in mind that what matters is sort of setting an interesting problem and trying to solve it in the long run if needed, and not trying to compare. I mean, it shouldn't be, unfortunately, it has become, but it shouldn't be the goal of a young, early researcher to have a career plan, to publish that many papers, but to get passionate about a problem and have the time to. So I'm a bit somehow I'm a bit disappointed to see this. It shouldn't become a dogma that we should mechanize everything to trust the results. I don't believe that at all. I mean, once upon a time, nothing was mechanized, and the papers didn't have that many errors. And even if you find a mistake in a theoretical paper, that mistake, I mean, it can be useful to find a mistake and progress on I don't see it as a, research is full of negative results as well. Or of, I don't know, that Gavin Law famous security protocol that was broken while, all the CSP community was quite confident about it. So these things happen, they are part of research. I don't see them as dramatic. Of course, if they are used for cyber in critical systems, okay, that's different, but this is not the kind of theoretical results which are targeted. So anyhow, I just want to say that I wouldn't be so pessimistic, and I wouldn't oppose the two.
So I don't think in any way I mentioned that the bugs are due to the fact that we're hurrying to publish. So I myself worked on a paper, spent a lot of time on it thoroughly. It got accepted to a conference, and just right before the camera ready, there was a bug in the proofs, and we withdrew it. And it took us a year more of work to make it better and actually publish it to a better venue. So it is exactly that moment that I myself thought, okay, I need a better strategy than this. And it wasn't because I was rushing to publish, because the paper got accepted and we withdrew it from the conference. We didn't publish it. So it doesn't mean that the bugs are a result of rushing and the competition and this vibe, everything you said. I think they are more related to what Marco mentioned yesterday. They are pen and paper, and sometimes you have 60 pages of proofs, and it happens because it's a human error. So that's the thing. So I don't see why then opting for something that would give you guarantees that they are correct shouldn't be the goal. That's the first. The second, what you're saying is that, well, it might matter, these errors might matter in cybersecurity and whatnot. And I mentioned this in my intro, that once upon a time we were talking about bookstore and addition mathematical server. But we might want to have session types in systems, embedded systems, real-time systems. You might have in the future examples of self-driving cars or the verification of plain software. So in those cases, then you better have the results correct. So it matters more than it did before. That's what I mean. Yeah.
Thank you. I mean, clearly there would be scope for more discussion about this, but I think we can move to another topic, and maybe we can get a couple of topics in before the end of the afternoon. So we've got Jorge's question on the stack, which was briefly, what do we think would be good strategies for getting funding for continued research in session types? So let's go to Ray first on this one, because he was last on the last one.
So, well, from my own background, I guess I'm biased. I have an interest in implementations and applications. To be honest, I'm not really sure to answer the great question. I suppose if we can find some of these bugs that have occurred, ones that hit the big news or something like this, if we can demonstrate just how, I forget who it was mentioning it just before, we can demonstrate just how serious faults in software, communication-based software and these things can be. That's clearly a good motivation for the correctness of this software. And just on the spot, I don't have the best examples, but I know in some last few years, you know, there were various incidents in the UK with the various financial institutions and causing, you know, however many, financial losses due to some software errors and things like that. So this is probably one thing that has real-world impact, I guess. Bugs, faults, errors, disasters, I suppose. And then of course, after pointing out all these potential disasters, you know, we have to find some stories that we can come up with to how we would deal, you know, prevent these and deal with these. And
do you want to go first? Okay. So a short answer: collaborate out of your comfort zone. So collaborate with people who you have maybe an intersection. You want to have an intersection in terms of topics, but also, of course, on the human level. That's more important almost. And then learn from them, and they learn from you. And I think this is nice how you find new applications of maybe tools that you're using now, or tools you can further develop. That would be my advice. Just get exposure with other, like, for example, I'm now working with someone who is really more a real-time system person, and that has helped me tremendously. And I think has helped us both, so.
Okay, so on funding, as a PI, I have 100% success rate of funding, but that's only one. So I submitted one, I got it, so maybe I'm not really the best person to answer. But the way I approach that, and definitely it's the way I will approach all future proposals, is when it comes to funding, the question is, the funding bodies are giving you money for what? And that's for addressing economic, societal problems. And are session types, then you can turn the question, are session types able to address any of these problems? And I would say, as we all know, absolutely yes. So from the moment that the whole society is built on distributed systems, then definitely we can cover that with session types. But it relates very much to what Ray was saying, that you need to, and that's where the proposal will come, you need to integrate then into your theory and development and whatnot, what the real systems then are bringing, which are failures, congestions, timeouts, and so on.
Okay, thank you. Those sounded like good points. So, hey, Hans, is this a new question or a further comment?
It's probably further comment.
Okay.
I'm just wondering if there aren't really two questions that are being, I wouldn't say confused, but being merged here. One is how do you live within the current landscape of funding? And that's what Stephanie's addressing. But another question is how do you change landscape? And I think if we're talking about the future of session types, we should probably address that other question more directly.
Okay, so that was good food for thought, Hans, in terms of building our networks to try to influence future funding calls and the directions that funders are interested in. So there was. Do you have a new question?
So I think there is an opportunity to bring session types more into the mainstream, because there's several people in the Rust community who want to add linear types to Rust, but they just need more ammunition for it to convince the rest of the community. And I think session types could provide that ammunition, and if that happens, then people could start using session types in their Rust programs. So I think that would be very nice.
Yeah, I wanted to follow up on that briefly. I think that's really true. And so we actually had, Frank and I, an ongoing collaboration with people of the server team at Mozilla Research. And they already explored session types on their own because they use all message passing concurrency. So server is a highly parallel browser engine. And so because of their interest, we started collaborating. And out of it came a session type library in Rust or EDSL, Ferrite. And sadly, Mozilla then restructured and the whole server team got fired. So, so for us, that's sad because I would have hoped that they maybe could use it. But I think I agree. I think there's interest, and I mean, server survived in other forms.
Yes. Okay, do we have any new topic? Which might be the last topic, depending on the length of answers and comments. Nobuko, a new topic?
So apart from mechanization, many people are interested in PL committee testing. And Martin talked about benchmark, but there is another way to test, of course. You can take benchmark and then sometimes you have many benchmark. It is like testing, so that instead of mechanization, and it's similarly model checking, we can do more like, you know, your theory is correct by checking by model checking. Then we find out the bug of the theory from model checking. Like this, you know. Is there any more, you know, because big distributed implementation, you cannot mechanize whether you implement correctly. So theory can be mechanized, but real implementation is very difficult. Large scale, it's very difficult to implement, mechanized. So probably there is another way to also test your theory or your implementation using more developing testing approach. And I'm not sure this community to think about more testing approach. And is there any people study testing and session types or implementations and more like benchmark?
So I haven't done work on that specifically, but of course what you're saying is absolutely interesting. I think there's two interesting points that you said there amongst many things. One is testing, and given protocols, of course, you know, as we know, the only way distributed systems work is because protocols already exist. What session types bring is some level of formality to this, right? And with a protocol as a formal artifact, it opens up a lot of opportunities. For example, test generation, automated test generation, you know, mock generation, stub generation, all these sorts of things which are very important to practical software development methodologies. Of course, monitor generation, or you know, full runtime verification generation. You could even do. Another thing that's interesting in what you said is, now I have to think, what was the other thing that you said? Give me a second. Yes, exactly. So I think maybe in particular with the implementations of multi-party session types, we sort of drifted away from the types. I mean, it's session types, but we got, in some works, we got less and less interested in the type system. We have multi-party papers where there isn't even a type system. It's the most boring part of the whole thing. So for the multi-party system, sort of we often, you know, quite a lot of papers often have a global types and a local types and some kind of correspondence between them, you know, preservation of fidelities or whatever it is you want to show between globals and locals. And that seems to be the hard part of checking whether your protocol is good or not in the first place. Assuming your protocol is good, sort of, and again with the caveat of the whole linearity issue, but if you have something like that or some way to get around that, just making your process, checking whether your process follows that structure doesn't seem such a a big deal in practice, actually, a lot of the time. And so, yeah, what you said is very interesting because, again, it sort of goes back to what is session types? What is an implementation of session types? Just you have your protocol specified in some way, totally statically offline verified by your favorite off-the-shelf verifier for concurrent systems, whatever it is, totally unrelated to session types. You know your protocol is good, and then after that, you just need to make sure your processes follow you know, the parts in that protocol. Is it session types? I'd like to hear what everyone thinks about that.
Do you have anything to? Well, you have the opportunity. Well, if Ornella or Stephanie want to comment on that topic, please do.
I think the main reason for mechanization having had so much focus so far is because the focus on session types has been a lot on the theory. Hence, we need to make sure that the meta theory of session types is correct. When it comes to implementation, what you rightfully said is that if you're implementing, well, a full language, then mechanizing is going to be difficult because of the size. And I think testing hasn't taken off because, well, we haven't even reached that stage with session types, that our implementations so far have been small prototype tools, and yeah, we've done maybe some testing, benchmarking in those tools, but the need for real testing, as you'd see in PL, hasn't arisen because session types haven't become mainstream yet. So I'm wondering if, so it might be a speculation, this one, that when that time comes that they will become mainstream, then maybe testing will come together with it as a necessity to make sure that they are implemented correctly.
So I saw hands up from both Jorge and Antonio. So were these new topics or further comments? Okay, Antonio had a further comment on testing then.
I think that there is another use for testing that is to address a very, very old problem, is that does our formal specification actually capture what we want it to say? And so we sometimes devise tests like runs, just say, this should not happen, right? And now, is my formal specification allowing this? Because if it is, it's not what I want. So testing as a way of validating that we capture correctly, because then we have the multi-party session type, let's say, and then the program actually follows it. But if the specification is allowing something that intuitively the client that told us do that specification does not want it to do, then it's wrong, right? So testing can also be this way of having like use stories or use cases just to make sure you actually captured what you're supposed to.
Well, I don't know anything about testing, but I know that testing is the reality in software engineering. So I think it's a very good point that that this somehow should be connected, right? So my point was actually a bit about testing, but also in the spirit of mechanization. So something that we have done in my group, mainly because we are not experts in mechanization, is to go to something that could be labeled as lightweight mechanization, and it's this idea of using this tool called mod, in order to formalize and to write the theories of session types into that level, and then you can have a way of a kind of of finding certain bugs in your formalizations at a relatively low effort. And I think this is a good interesting thing because it's not really as heavy in terms of load, in terms of like going directly to COG. It also allows you to test your specifications or your theories to some extent, right? So if there is something that is evidently very subtle, you can already try to catch some of these things. So some of the first experiments that we have done is have to do with formalizing, for instance, the type checking algorithm that Vasco formulated in the fundamentals of session types, right? So we
we managed to actually implement things completely. So I think this is actually a halfway between going full mechanization, which is costly, which requires a number of years, talented people, and money, and something that allows you actually to get some trust, because indeed the main issue is trust, right? And testing also is part of that picture, because with those tools, with those rewriting frameworks, actually you can do a bit of testing also of your specifications.
So I think that brings us pretty well up to time, and so we should bring things to a close. So first of all, thank you to our panel members, Stephanie, Ornella, and Ray, for their insightful contributions to the discussion, and thank you all for the questions and for the further discussion, in addition to the panelists' comments. And so finally, this brings the workshop to a close. So let me finish by thanking all of you for coming and participating, and the speakers for contributing their talks, and also, of course, Diana for co-chairing, and our assistants who've been in the room helping whenever we needed them, and the program committee members, and also the other members of the organising committee. So we hope you've all enjoyed the workshop, and I look forward to seeing you all again at whatever the next meeting is that brings us together. So thank you, everyone. We can. I'm not very sure where. I mean, the only website is within the Splash website, so I'm not exactly sure where we would put slides. The authors can attach them to their own talk information. Ah. Okay, so if you wish, you can put your slides in the information with your talk. Yeah.